Yesterday we had a very good, wonderful, tutorial come workshop where I'm very happy and pleased that you all interacted very nicely. You studied the material, the paper, good research paper that was applied by foreign expert Dr. Alex, and he was also very impressed the way you presented, the way you analyzed, and everything went on. It was a long session, 2.5 hours. Uh, so today again I'm going to talk on an important issue: Indian perspective of climate change, economic vulnerability, and displacement. So there are two issues. One is that of the climate change aspect, vulnerability, displacement, and what Indian perspective, what the government of India and what country, our country, is doing to combat the climate change. Right. So then after that, uh, we have another lecture by foreign expert, and then after that, I'll demonstrate the data set that will be used for modeling climate change vulnerability. As I told yesterday, so for that I'll demonstrate here, and then we'll move to the lab post lunch for a long session, maybe 2 hours, 2.5 hours, 3 hours even. And if you enjoy, I'm sure you'll enjoy, so that may go on even longer. And for that, I'll request the participant that those who are having laptop, and if they do not have the software, GIS software, ask my scholars and volunteers that they will install parallelly in the sitting in room. Something which is not exactly software, but something which may help that. In our lab, we have the software, very good labs, very powerful system, and a software. So we'll do the modeling. I'll demonstrate, and you'll do yourself. We'll provide the data, soft copy of the satellite data, IMD data, and then you'll be modeling that. Right. So the issue is that Indian perspective on climate change. I'll speak on Indian perspective later. But let us talk about again coming back to the entire issue, our planet Earth, our Mother Earth, which feed us, which provide us the water to sustain life. So there is statement, very important statement. What it says, the Earth is finite. Its ability to provide food is finite. Its ability to provide energy is finite. Its ability to absorb waste and destructive effluent is finite. Huh? So there is common word, and that is finite. Huh? This finite is a very important word in this context, and we do not feel concerned about it. We feel that everything is infinite. We can use the resources as per our own wishes, not the need, as per our own wishes. So it is finite. So this is very important statement. And then what we have, moreover, we are fast approaching many of the Earth's limit. Current economic practices that damage the environment in both developed and developed nations cannot be continued without the risk that vital global system will be damaged beyond repair. And that is a statement that was given by GEG Natural Resource Journal, that was published way back in 2011. But still, that holds thousands and thousands of meaning, very significant meaning. So what it says that the moreover we are fast approaching on the many of the Earth's limit, limit that is to provide the food, to provide the energy, and even to where to dispose of the waste. That is another big issue in many parts of the country and many parts of developing nation, and even the westward also. Westward is not that much problem. We are fast approaching many of the Earth's limit, and we are moving in a way that the risk that the whole entire this blue planet, what we have, beautiful planet, what we have, is going to be damaged, that the global system will be damaged beyond the repair. I'll give an example how we are damaging our Earth. We do not feel concerned about it. If you get hurt somewhere, get some, get cut on a finger, on a legs by chance somewhere, and if it is small, what do you do? You go to any dispensary or you go to chemist shop, you apply Band-Aid. And in a day or two, it heal up. But what happens, sometime if you get fall down, touch wood, maybe, God forbid, किसी के साथ ऐसा ना हो, you fall down and leg and hand get fracture, that takes long time to get it repaired. And also, if you are old, so it cannot be joined. So similarly, we are interacting, we are using the resources which are there on our system. So the entire, I'm not going to show bigger thing, but the important issue that one need to understand, and the entire objective of this workshop is to understand better, not just to do science and to do better research, but to manage and feel concerned about the nature, environment, and climate change, so that we can get benefited with the ill impact, or we put lesser harm to the planet Earth and all. Now, as I said that we always blame the population for every problem, right? So if you see the population as per United Nations 2011 report, 7 billion population, and that has been painted in one color. But it is not so. Population are different in different countries. So if you see the continent wise, this is the picture. The statistic what it shows, the largest 3.6 billion Asia, then Africa, then Eurasia and America, and so and so. Now this also doesn't give a better picture. What we do here, we go for country wise. So what we see here, the largest population is in but natural India, China, and many of the Southeast Asian countries. So it doesn't mean that the population is uniformly distributed everywhere. And I said yesterday that a ratio figure that gives you the best impression of anything. Let us see the ratio figure. That is population density, right? So what we find that if we talk about India, in earlier slide it was painted in one color. Now see Indo-Gangetic Plain, southern part of India, coastal India, western, and some other part which is highly densely populated. And you see, if we talk about China, eastern coast of China, eastern part of China. If we come to America, what we have? The coastal part of eastern America, western coast of America, central America, something like that. So where all these population concentration is. And accordingly, we need to provide the resources, we need to do whatever we want to do. Now, let us see the growing global population or shrinking Earth. Everything is connected with the Earth. And what are we talking about climate change? Is linked with the Earth's activity that is being performed at the Earth's surface, at any parts of the world. If any activity is being performed on any particular part of surface or other, that is not being impacted much, but some other part of the Earth is being impacted because of the different reason, air circulation, wind movement, ocean currents, and so and so. Earth's rotation, revolution. There are many more factors that you all know. So what we have? See, the Earth is shrinking. In 1900, the per hectare land per capita was 7.91. In 1950, it reduced to 5.15, 1987, 2.6, and then 2005, close to 2. By 2030, is going to be 1.69. So, Earth is not shrinking. No, Earth is the same. Is the size same? No change. But what we need to understand here, what this glimpse, this gives you a glimpse that the Earth is being shared by larger population. By larger population. That means the resource, some of the most important resource, the most important resource is the water, and then the land. Followed by gold and diamond, what all, what not. If you have get some money in your pocket, if you save some money, what did you? You go and buy a piece of land. पानी तो जिंदगी जीने के लिए, सांस लेने के लिए पानी तो ही है. जमीन खरीदते हैं, मकान खरीदते हैं, फिर उसके बाद बाकी चीजें खरीदते हैं. So land is very precious, you know. So what we have, the land is shrinking in a way that when the population increases, and if we divide with the land surface area, whether arable land or land which where you can build any economic activity or houses, that is going down. In a way that if I give an example, okay, a family has a 4 child and he is a say 40 acres of land. So what will happen? 10 acres to each member, whether it's a boy, girl, whatever. And then the same boy, if he grown up, get married, again 4 child, then get divided, segmented, 2.5. Then further, if has 2 or even, the population is increasing, so the share of land is shrinking, right? And the population, what we say, we always talk about population is a big problem. So, different countries had adopted population control, family planning and all. And those countries who have applied, started family planning, be it Russia, be it China, they are facing a grim consequences of that smaller population, productive population. We are fortunate enough that we have very young productive population in India. So this is one issue, that is a growing global population or shrinking earth. So these are some issues that I want to put the background before we jump into the climate change issue. Now if you see, urban India will drive a near fold increase in average national income. We all know that this is the urban areas. Study foreign expert talked about that, and also talked about that it is the urban areas which is the main culprit of changing climate of any part of the world. Less contribution in the changing climate is coming from the rural area, but more is from the urban area. I can share and I can give you some example. Number one and number two, economic growth, faster economic growth. So economic growth followed by urbanization and urban population increase is one of the main drivers for climate change. Now let us see some statistics, very important statistics that has been given by India's urbanization economic model, McKinsey Global Institute analysis report. What it says from 1990 to 2030, what we have. If we compare with the rural areas, all India and urban area. So what we have, the GDP growth 6.5% and then 7.4%. Population growth 1.8 and it has reduced to 1.1. Now see this one. In 1990, rural India, what was the state of per capita disposable income? Rupees 1,000, real 2008 data. Then it is slowly increasing rural area. Whereas the urban areas, what we have, the per capita disposable income is going at a very faster rate, which was say 5.4 in 2005. It has gone to 6.4. And sorry, this is a compounded growth rate, and income has gone 239 for the urban area. All India is little high. So what we have, with the changing pace of time, population growth has little gone down, whereas the GDP growth has gone little bit up, and projected by 2030 what we have here. Now this global statistics is very interesting. That is the data from IMF, International Monetary Fund, what we have. From 1982, let us see some statistics of economic growth. As I said, the urbanization and economic growth. Economic growth is the most important driver. Economic growth. This is what we have, the nominal GDP of the world. From 1982 to 2018, what we have, the GDP is increasing at a very fast rate. Now if you see the country-wise, China, Euro area, United States of America and Japan, all countries has recorded faster economic growth, GDP, right? That is very good. Everybody is looking to increase their income. हर आदमी चाहता है, एक छोटा कारोबारी है वो भी चाहता है कि आज हमने 1,000 रुपये कमाया, कल 1,500 रुपये कमाया, अगले साल 2,000 कमाए. हम भी एज ए टीचर सोचते हैं कि साहब तनख्वाह जो मिल रही है, 8वां पे कमीशन नहीं आ रहा, रोज हमारी यूनिवर्सिटी में बात करते हैं लोग, सरकार ने कंस्टिट्यूट कर दिया, गुड न्यूज। सो व्हाट वी हैव कि साहब ये इकोनॉमी, हर आदमी चाहता है कि पैसे खूब आ जाए, यू नो, पैसे किसी को, लक्ष्मी किसी को खराब नहीं लगता, बट इतना भी नहीं अच्छा लगना चाहिए कि उसका नुकसान हो। दैट इज द मोस्ट इंपॉर्टेंट, राइट? सो आई पर्सनली बिलीव, तो आई हैव एक्सक्लूडेड सम ऑफ द स्ट्रेटजी जिसमें हम आपको देखते हैं कि क्या है इकोनॉमिक ग्रोथ। इंडिया का भी हमने रखा था, बट आई बिकॉज यू नो वी हैव लेसर टाइम, सो आई स्केप दैट। सो दिस इज स्टेट ऑफ अफेयर ऑफ इकोनॉमिक ग्रोथ, वर्ल्ड जीडीपी, एंड सेम इज ट्रू विद इंडिया। इकोनॉमिक ग्रोथ हमने कल बात किया था, इकोनॉमिक ग्रोथ is going up, economic condition of the country is very good, you know, government has made good policies, and from the last quarter to this quarter the economic growth has increased, you know, to about 0.5 0.6%, right? So what we have, when the economic growth will take place, you know, what will happen is but natural. This is a very interesting slide, and I'll spend some time on this. What we have, if we compare the population and material, what we have in 1970 and 2010, this is a non-metallic minerals, right? This is a metal ores, this is a fossil fuel and biomass. If you start from non-metallic minerals, it was, you know, billion tons, little close to 1 billion, right, tons. By 2010, what has happened? It is 5 billion tons in only say 40 years of time. And if we take the data of 2025, it will be much more, right? So what we have, since 1970, population increased 5 times, right? And if you see this one future scenario, even current dynamics and material demand will grow 5 times by 2020. Now, if we see this one, this bar, what we have, this is the same thing. Scenario, slow down development process. Scenario, continuing current dynamics, the second one, and scenario, fast catching up. So when you try to fast catch up with the other countries, this will go up much faster, you know, material consumption. And what happens, a very fundamental issue is that the moment you get money in your pocket, तो फिर आपको you feel to buy something. It's but natural. जब जेब में पैसे नहीं होंगे तो आप you do not go to market and do not spend. You do not buy goods and services. Material की डिमांड कम होगी, you know, कंजम्पशन कम होगा और डिमांड कम होगी. मटेरियल कहां से आते हैं? It comes from मदर अर्थ. This is what I said. पहले 2 वक्त खाते थे लोग, सुबह और शाम को. If you talk about the rural areas or Indian, most of Indian part, अब क्या है कि सुबह एक बार नाश्ता, फिर दोपहर में लंच, शाम को एक बीच में स्नैक्स, है ना, फिर रात को लंच डिनर के पहले फिर कहीं बैठ जाते हैं, कॉफी पीते हैं, पिज्जा खाते हैं, बर्गर खाते हैं. वी कीप ऑन ईटिंग, एंड दैट विल ओनली हैपन व्हेन यू हैव मनी इन योर पॉकेट. पैसे नहीं है तो फिर आप जो है मन मार के अपना घर चले जाओगे. घर के लिए कुछ लेना भी जाओगे तो नहीं ले पाओगे. लेकिन जब पैसे होंगे तो क्रूड वर्ड, बेयर विद मी, हाथ में खुजली होती है? बच्चों को कहोगे चलो कुछ दिला दें, वाइफ को कहेंगे लोग चलो तुम्हें कुछ दिला दें, है ना? होता नहीं होता है? तो आई एम नॉट सेइंग दैट दिस इज बैड, बट यू स्पेंड मनी एक बैलेंस वे में. आप चीजों खरीदो, कंज्यूम करो एक बैलेंस वे में. एक कोई चीज आपने घर में रखा, कोई अप्लायंसेस, वो सब कुछ ठीक है, उसके बाद भी आप कहोगे इससे बड़ा ले आओ, इससे अच्छा ले आओ. यू हैव अ टेलीविजन of a smaller size, आप कहोगे 32 इंच ले आओ. 32 इंच था, आप कहोगे 64 इंच ले आओ. And there is big problem of solid waste, e-waste, that is coming up. That is again an important issue when you are talking about climate change and environmental pollution and degradation. आपने कहीं dispose off कर दिया, वो dispose off भी ठीक से नहीं हो रहा है. So these are the issues. So what I am trying to show you is that कि साहब देखिए 2016 का डेटा है, UNEP का है. The material consumption, non-metallic minerals is going up very fast. When I talk about non-metallic minerals, the iron ore, aluminium, many more, वो कहाँ आ रहे हैं? कंस्ट्रक्शन में आ रहे हैं, बाकी चीजों में आ रहे हैं, you know? तो what we have, the material consumption is going up. Fossil fuels. See this one. Very thin line here. But by 2010, it is widened. Fossil fuel. Burning of fossil fuel. That is one of the main culprit. I'll show you some slides on that. Alex has already showed you. कि आपने कार खरीद ली, स्कूटर था, अब कार खरीद ली. स्कूटर में आपको 5 लीटर बर्न करते थे अ मंथ, अब जो है कार में 15-20 लीटर आप बर्न करते हैं. वेयर इट इज गोइंग? फैन से अब कंफर्ट नहीं आ रहा है. यू हैव बॉट एयर कंडीशनर, नॉट जस्ट इन वन हाउस, इन वन रूम इन अ हाउस, बट यू हैव प्लेस इन ऑल रूम्स. यू नो, पहले पंखे में नहीं होते, अच्छी नींद आती थी, अब एसी में भी नहीं आती लोगों को. You know? So these are mental comfort. And if you link with the nature, link with the climate, then you realize कि what I am doing, how I am interacting with the resources. तो resource का जो हम बात कर रहे हैं यहाँ पे कि India's material consumption growing, you know, sharply, कि resource consume करो but in a proper way, justified way. And this is what I said yesterday कि अगर जो हम एक आदमी, हर आदमी अपने को थोड़ा सा सोच के right left देख के चले तो everything will be perfectly fine. You know. So this is a very important issue. So what we have, okay, material consumption has gone at a very faster rate. Now, say this one. This is an internet picture. I put it. I do not know exactly the source, but if you Google, you'll find many more. What it shows? Systematic problems. On the left picture, what it shows? Production system, and right side shows consumption pattern. That speaks a lot, these two pictures, to me. And if you think and concentrate and understand, see what we have. Systematic problem. पहले फैक्ट्री थी, सीजनल चलती थी, सुबह से शाम तक चलती थी, शाम को बंद हो जाती है. अब 24 घंटा. You need more and more energy. Take this classroom. Forget everything. When we were a student in our hometown, in room there were one tube light and one fan or two fan. Now see, in our room, so many lights. Although these are the good light LED, they consume less energy. Centrally air conditioned. You know, from where it will come? It will obviously come from either thermal, hydroelectric, nuclear, whatever. So to produce something, you need some material. You know. So this is a production system and then consumption pattern. This is somewhere in America or Europe where big shopping malls are there, but buyers are less, you know, because they have lesser population. If you go Indian scenario, you'll find many more in narrow lanes of the shopping mall. So this is, to me, that this is also a problem, huge emission of various gases and many more things, and right size to produce goods and services that we need. हमारे बच्चे, हम सब लोग, छोटे छोटे रैपर्स में जो चीज़ें प्रोड्यूस होकर आती हैं, गुड्स एंड सर्विस, उसको कंज्यूम करते हैं, उसको यूज़ करते हैं. एंड दैट बिकम्स वो गलत नहीं है. पहले क्या था? सॉलिड वेस्ट इज अनदर एनवायरमेंटल प्रॉब्लम एंड इश्यूज. पहले क्या था? इफ यू रिमेंबर कि हम एक बैग लेके जाते थे घर से टू बाय सम गुड्स एंड सर्विसेज, सब्जी खरीद के ले आते थे. अब क्या है? जेब में हाथ डाल के जाते हैं और जितने सामान उतने पॉलीथीन. इट्स वेरी सीरियस थ्रेट. सरकार इज डूइंग अ लॉट कि साहब इसको मत यूज करो, सिंगल प्लास्टिक यूज, प्लास्टिक बैन वगैरह, बहुत सारे लॉ किया, लेकिन हम मानते नहीं. ना दुकानदार मानता है ना हम मानते हैं. दैट इज अ बिग प्रॉब्लम, इजंट इट? तो हम लोग एक थैला लेके जाते हैं, उसमें गोभी भी है, आलू भी है, टमाटर भी है, टमाटर टूट भी जाते थे बहुत सारे, उसमें धनिया भी है, हरी मिर्च भी है. घर लाने के बाद उसको सेपरेट किया जाता था, इजंट इट? वी डोंट डू दैट. So these are some of the basic fundamental question and the issue that one need to understand. Now, say this one. This is again the systematic issue, systematic problem. What we have? So many cars has been parked. It's not in India, I'm sure. Somewhere in westward, developed nation. सलीके से पार्क किया गया है. हिंदुस्तान में पार्क कर दो तो कोई निकल नहीं पाएगा. Isn't it? Must be a corporate word. पीछे देखिए टावर बिल्डिंग है. So all these cars have been parked. So what will happen? Again, I'll say economics. What I showed you, the economic growth. कि the moment you get money in your pocket, आप कहोगे भाई स्कूटर में मजा नहीं आ रहा है, कार खरीदो. अच्छी बात है. That is a good indicator of development. Car per 1,000 of population, 4-wheeler per 1,000 population. उसमें कोई बुराई नहीं है. पार्किंग नहीं है, आप कार खरीद लोगे एंड देन सरकार ने बहुत अच्छा किया कि भाई इफ यू हैव अ पार्किंग देन यू कैन बाई अ कार, अदरवाइज यू कैन नॉट. लेकिन फिर भी हम खरीद लेते हैं वन वे और अदर. So what we have, the more money you come in your pocket, you will go and buy a car, and it's very easy to afford a car. If you have a 50,000 rupees in your pocket, you can buy a car of 5 lakhs rupees. Different globalization and liberalization that has come. The banks has come, n number of banks have come. Every day you get a call, is have loan le lo, plot le lo, isn't it? And you buy a car. So what will happen? यहाँ तक भी कोई प्रॉब्लम नहीं कार खरीदना. What will happen? Per capita energy consumption will go up. Per capita energy consumption will go up. As per World Bank report 2012, 1960 C and 2010, the per capita energy consumption of India was very less, slightly increased. This y-axis, the value is very high. If you expand it, so you'll find in India the per capita energy consumption has also gone up. But if you see the per capita energy consumption of France, Germany, Norway, Canada, United States of America, it was very high even in 1960. That was 2,000. Here you have 4,000, you have 6,000, and it has gone little more. And that is the narration what he used to study, in a class, or what I've been taught and we teach. Ki rich nations are the more emitter, a polluter than the poor nation. Poor के पास उतना है ही नहीं. But in India also, जो हम ये देख रहे हैं, अब लोगों के पास कार आने लगी है और emission होने लगा. If I tell my example, when I came Delhi in 2000, I had a scooter. I used to purchase 3-4 liters for a month. Now after a certain period of time, I got a loan and bought a car. It started, consuming 25 liters of petrol, now 35 liters of petrol. So obviously the emission will go to the atmosphere and that will create a problem, right? Now see this one, total energy in petajoules for 2022-23. This is the latest figure. As per report that has been published in Environmental Statistics 2024, Environment and Account 7th issue. What we have, petajoule is equal to 1 million billion joules. 1 million billion joules, that is 1,115 joules or 278 gigawatt hour. So in 2015 and 16, it was 84,000 something, and by 2023 it has gone to how much? 1,02,073. This is the latest figure. Now if we say this one, in which sector how much energy is being used? 2023 data, household 5%, other industries 31% maximum, electricity, gas, steam, air conditioning supply 28%. So this was quite less. Manufacturing 28%. So this is the state of affairs from where all this energy is being used and how much. That is another issue. What will happen? The emission of CO2, as per IPCC's 6th assessment report 2022, what we have. In 1990 to 2018, Middle East, Africa, Eastern Europe and West Central America, Latin America, Asia and developing Pacific nation and developed countries. See, as I said before, if you see the earlier slide, what we have here. In 1960, the consumption of energy per capita was very high, 2,000, 4,000, more than 2,000. The same is here. The same is here. What is here? Production, total CO2 emission for 116 countries based on production and consumption emission. See, CO2 emission, gigatons CO2 per year, ton. And other countries was quite less. See, Africa and West Central Asia and including India, the net import and export. If we do not have the energy, we import. If you do not have water, we import. Earlier, it was a natural cycle. We got today a lot of rain, very heavy rain in Delhi. And therefore, some of the participants, those who are from Delhi NCR, they stuck up in them, on the way. They are joining slowly coming. So what we have, you use the water, consume the water, and the same amount of water get recharged by the rain. But what we see today, the rainwater is being drained out and going to the drains, and that is going to the rivers. There's no option of recharging because of concentration of the urban areas in the smaller cities. So consumption is not an issue. The way you consume, the same way you have to supplement, you to add. In a way that if you have in a bank account 5 lakhs of rupees, you keep on withdrawing and withdrawing, a day will come, it will be exhausted. But what happens? You withdraw and then you get a salary, or you add something, then the balance will be there. So naturally state of environment will be maintained. So this is the state of affair. Now see, major economics with their total and per capita emission of CO2. Lakh ton of CO2 equivalent. Y-axis you see, Canada, Russia, USA, Japan, Italy and India. Say this one. And total CO2 equivalent. So as per Economic Survey 2023 and 24, that is state of affair. Right? This is the greenhouse gas emission. This is greenhouse gas emission per capita. This is the emission. You see, China. We all know that in the entire world, what all we see, the goods and services, mainly goods, they capture the entire world. Their production system is very strong. If you go to any European country, developed nation, if you pick up any product, that will be made by China. Even in India. Right? Low cost and good quality. So what will happen? Greenhouse gas emission is quite high. See the big bar. India is also quite high. India and then USA. And then obviously what will happen? The greenhouse gas emission will be more. Now see the greenhouse gas emission across supply chain for various food products. From where all these greenhouse gases are coming out? The food products. Beef, dark chocolate, lamb, mutton, beef, dairy, herd, cheese. So these are on the top, right? Dark chocolate. Everybody is fond of chocolate, not chocolate, but dark chocolate. That is most fascinating. I don't have a slide when I give a lecture on water resources. I tell how much water is being used to produce 1 kg of meat, 1 cup of coffee. If I give an example, to produce 1 cup of coffee, you need 150 liters water roughly. And to produce 1 cup of tea, need 40 to 50 liters of water. And to produce 1 kg of meat, you need 8,000 liters of water. Now again economics come into picture. जेब में पैसे आएंगे तो चाय अच्छी नहीं लगेगी. कहोगे कैफे कॉफी बेचो, क्या फाइन कॉफी होती है. So that large amount of water is needed. You'll be wondering कि इतना पानी काहे के लिए? Right from seeding to growth and processing and up to the putting that product, the tea or coffee, to the market. The large amount of water is needed. So it's good to use coffee, drink coffee, but पानी तो हम withdraw कर लिए, फिर पानी recharge नहीं हो रहा. That is the issue. That is a big issue. That one need to understand. Rather than talking big thing for the climate change and other issues, right? So what we have, आप देखिए इसमें cheese, coffee सब में quite high and greenhouse gas emission per kilogram of food product. 1 किलोग्राम पे फूड प्रोडक्ट में बनाने पे कितना हमें यूज होता है? से यहाँ पे देखिए 120 as per this data, 180 and so. So that is another big issue that one need to think on. Now, low carbon economies and the total per capita emission. Low economy जिन countries की है उनका देखिए Green Future Index and annual greenhouse gas emission per capita tons of CO2 equivalent per year. So what we have? Ireland, Finland, UK, USA and India. Other high GDP countries are Italy, USA, China, Japan, India and Russia. And these are the top low carbon emission per Green Future Index 2023. So these are some of the statistics that has been recently published in the Green Future Index 2023 MIT Technology Review. So these are some of the data one need to see where we are heading to, how our economic growth, how our urbanization, how the consumption pattern is taking place. No. As I said yesterday, once we have more money in pocket and once we are getting richer and richer, we want to build a house and we want to buy a house in somewhere else also. We do not want to live in just single house. You have another house. And if I see in my university and in Delhi, my other institutes and other institutes in Delhi, the people do own a house in Delhi NCR and also in the hilly areas. So what will happen? See this one. Primary forest lost. That is another big issue. From 2002 to 2024, India lost 348 thousand hectares of humid primary forest, making 15% of total tree loss in same time period. The total area humid primary forest in India is decreased by 5.4% during this time. Now see this one. Area of tree cover loss within 2001 primary forest, percent of 2000 primary forest loss. See this one, 2001 to 2024. This is a forest loss. No? In 2020, India had 44.4 million hectares of national forest, extending 15% of its land area. By 2024, it lost 150,000 hectares of national forest, equivalent to 68 million tons of CO2 emission. Had it not been the loss this much of forest, it could have absorbed, it could have consumed 68 million tons of CO2 emission, thereby, protecting your nature and environment from the global warming and climate change. So we are least concerned about it. पेड़ काट दो देखा जाएगा, चाहे right or wrong. And government of India has made very strict policies. Cannot cut a tree. High Court comes into picture, Supreme Court comes into picture, and they give strict, judgment that you should preserve the forest. So, for the want of more economic growth for economic activities, what we do, we keep on cutting, we keep on doing whatever we want. So, what will happen? The moment we have the more and more, forest resources cutting, and what will happen? Obviously, that will lead to increasing, global temperature. That has been showed. I think this report as per Barclay report 2023, March 2023. See the temperature from 1860 to 2020. Very long term data. And to see the climate change, you need to have a longer period of data, whether temperature or rainfall. And this is for 160 years of data, right? So what we see, if we plot the average temperature is going up. And what pace, at what rate, it is before you. That is already been discussed. I'll not go much on that. Now, you see this one, charting 15 years of heat. This is for the entire India. And this is a recent report that has been published by wriindia.org on that. What we have, 92% are exposed to more than 6 hours of heat stress. And if you go on that site and you put that rate, you will get for different date. And also they flush. Okay, 5th April, 10th April, 15th April. So I chose just one because of time and all. So what we see, the people living here, see here at this Karnataka and Maharashtra, they are exposed to 18 hours of heat, 12 hours, 13 hours. This is hours exposed to strong and above heat stress, bro. If you go to Delhi and many other parts, this area, we have on an average 92%. Imagine 92% people are exposed to heat. Yesterday, Alex made a remark in his presentation that people are not so much exposed to heat. Elderly people, those who are living in the Europe, America, Canada, and UK, they get exposed to it and they die. हमारे यहाँ we are vulnerable too, but we have adopted. Adaptive capacity of heat or extremes of pollution is in our blood. We adopted too. That is not good. So what we have in 2024, India experiences unprecedented heat wave with several cities recording temperature above 45. My cousin live in Kuwait, and he sent a screenshot. Okay, last week they experienced temperature of 56 degrees centigrade. Gulf countries experience high temperature, doesn't matter, but not much higher, 50, 52. But this year they have experienced 56 degrees centigrade. And many of the world leaders, they are talking about that there is no climate change and nothing is going to be worried. Yes, true. We all know as a geography student and that Earth is full of cycle, heating equally. But this period, what we are, is a period of heating. There are different reasons for that. You all know. So what we have, about 90% I have already explained. The 2024 was the warmest year on record on the Earth's surface, and the first year with the global average temperature exceeding 1.5 degrees centigrade above pre-industrial level, signal pressing need for cooling solution, heat responses, adaptation and mitigation measures. And one need to understand, one need to think of it. That is real, that could be the real solution. Otherwise, we keep going. Now, it is but natural. जब गर्मी होगी, हम बाहर निकलते हैं गर्मी में 40 डिग्री टेम्परेचर, पसीना निकलेगा, पानी निकलेगा, निकलता है नहीं, किसी एज का हो, कोई भी हो. द सेम इज ट्रू फॉर द अर्थ. जब टेम्परेचर बढ़ेगा तो जो स्नो आइस हैं वो मेल्ट होंगे. I'll not show much slides, but I need to let you understand. I want to sensitize the young generation. I always tell my students ki saab, think of it. Do not look right and left कि वो क्या कर रहा है, ये क्या कर रहा है. Think yourself what you're doing, how you're interacting. So what will happen? See this one. National Snow and Ice Data Center NASA का in 1994 6.7 million square kilometers of snow and ice was covered at Arctic Sea. And by 2012, what has happened? 3.41. And see the white patches. White patches is reduced. Say this one, this is fresh, snow and ice. And not only the area, another very important issue is the thickness of the snow and ice. How thick is it? And if you concentrate on this circle, what I put it, very bright white patches. That is reduced here. The thickness is also gone. The extent is going down, and areas receding, and thickness is also going down. And I always feel and believe, and I tell my scholars and students that water, this is the snow ice cover is a fresh water reserve. That is a reserve. Reserve in a sense, again I'll give example, कि वैसी रिजर्व है जैसे हम पैसे को फिक्स डिपॉजिट कर देते हैं, करते हैं ना. जब पैसा एक्सेस आता है तो कहते हैं कि इसको फिक्स कर दो, इसमें इंटरेस्ट ज्यादा मिलेगा. अगेन इकोनॉमिक्स कमिटी पिक्चर है, उसको तोड़ नहीं सकते हैं. बहुत मजबूरी में है ना, एफडी वगैरह कोई उसको कैच कराता है, जिसको कॉमन वर्ड में तोड़ना कहते हैं. तो ये स्नो आइस ऐसी है, फिक्स डिपॉजिट कर रहा है, इफ आई एम नॉट रॉन्ग एंड इफ यू एग्री विद मी. और जैसे ही वो बैंक से निकाल के आप जो है उसमें लाते हो जेब में, तो दैट बिकम्स लिक्विडिटी. कब खर्चा होगा आप कहते हो ना, 1000 रुपये जेब में था, कब खर्चा होगा, कैसे खर्चा होगा, पता ही नहीं. द सेम इज ट्रू विद दिस in terms of climate change. I'm talking in terms of climate change. I'm not telling you a story. I'm linking the daily day-to-day issues that is. तो जैसे ही ये टेम्परेचर बढ़ा, तो क्या होगा, ये मेल्ट होके, अब मेल्ट होके कहाँ जा रहा है? It goes to the rivers, and rivers goes, the fresh water goes to the river, and river goes and meet the saline sea water of no use. उसको कैसे हम प्रोटेक्ट करें, डैम बनाएं, कहाँ रोके, that's a big issue. So what has happened? तो ये जो चीजें हमारी आपकी हुई, why? Because of the climate change. Although there is thawing also, freezing and thawing going on, but this is happening. What we have? आप देखिए 2024 का इंतजार बैठे हुए हैं. आयास की भाई तो बहुत पुराना डेटा हो गया, कुछ महीने पहले हमने कहा कुछ निकालते हैं, तो we explored and we got 2024 डेटा. 2024 में देखा, 2012 तक फिर भी ठीक था. आप देखिए 2024 में 4.7 मिलियन एरिया हैज एक्सटेंडेड, बट थिकनेस देखिए आपका, व्हाइट पैचेस इज गॉन. दैट इज स्टेट ऑफ अफेयर, राइट? सी ये हमारा आर्कटिक का था. नाउ लेट अस सी अंटार्कटिक स्नो एंड आइस कवर. In 1981, this was state of affair. In July 2024, say this snow ice cover, this is 100%, this is 0%. This is 0%, this is. So we can see, compare in the last, say, 40, 45 years, what has happened. You see this one, white patches, bright patches, white patches, extend, and this one. Same is true with this, जो हम यहाँ पे देख रहे थे. This is a melted water, and this is a fresh water deposited in snow ice cover. Now, this is a site, you can go on this, and you can choose the month, year, and day, and can have what is state of ever, a long historical data you have. The website I have put it, National Snow and Ice Data Center, of NSIDC. The link is on that, nsidc.org.c-ice. Now, another issue. कहते हैं ना, पिक्चर डू नॉट लाई. लेकिन आज की डेट में AI के जमाने में पिक्चर ऑल्सो लाइज, है ना. एंड पिक्चर्स गिव्स यू मोर स्ट्रॉन्गर अंडरस्टैंडिंग देन द टेक्स्ट एंड देन द फिगर्स. हम फिल्म देख के आते हैं, सालों साल याद रहता है ना, चाहे शाहरुख खान की फिल्म हो या अमिताभ की हो या दिलीप कुमार की हो, सारे सीन, सारे डायलॉग याद रहते हैं. अगर उसको नॉवल में पढ़ ले तो शायद कुछ दिनों बाद वॉश आउट हो जाता है. सो इन दिस वे आई हैव पुट इट. सी अराल लेक, जो एशिया वर्ल्ड की 4th लार्जेस्ट, वन ऑफ द लार्जेस्ट. व्हाट इज स्टेट ऑफ अफेयर? 1977. कल आई शोड यस्टरडे इन माय लेक्चर द पावर ऑफ रिमोट सेंसिंग GIS, इन अंडरस्टैंडिंग द नेचर अर्थ, अंडरस्टैंडिंग द अर्थ सरफेस. और उसका फिर आप, दिस इज नथिंग बट अ लैंडसेट डेटा, स्क्रीनशॉट ऑफ रॉ सैटेलाइट डेटा जो लोग यूज करते हैं. आई एम श्योर दैट बहुत सारे बच्चे यूज करते हैं इसका. लैंडसेट डेटा 77 में दिस वाज द अराल लेक का शक्ल ये थी. ये फ्रेश वाटर है, ब्लैक पैचेस फ्रेश वाटर है, ये वाटर नहीं है. एंड इन 1989 ये एक्सपोज उसका बेड लेक का, ये लैंड दिखने लगा. और 2006 में आने के बाद ये वाटर श्रिंक कर गया. These are sediment that has been deposited and these are fresh water. और उसके बाद फिर देखिए क्या हुआ, उसके आगे फिर इसको भी निकाला गया. 2014 में आने के बाद क्या हुआ, 2024 में. Right? Where we are heading to with the withdrawal of water, with the use of water, or for our own gain. So the state of affair what we see from 1977 to 2024. That one need to understand. How to check the grim consequences of the increasing temperature, declining fresh water, or whatever. I wanted to put one slide, but I forget. In the morning, I came early to go to department. In the university campus, there are 6-8 inches waterlogging, so I could not go. Otherwise, we did one project of Hyderabad. In Hyderabad, there was more than 400 small water bodies, and that is all gone because of two reasons: erratic rainfall, and second is developmental activities. जो आपके पॉन्ड से, उसको आप गांव में भी देखे होंगे, जो पॉन्ड से तालाब हैं उसको फिल इन करके धीरे धीरे इंकोच करके उस पर इकोनॉमिक एक्टिविटीज, हाउसिंग वगैरह सब बन जाता है और उससे चली जाती है. तो दैट इज अनदर वेरी इंपॉर्टेंट स्टडी. आई मिस्ड इट टू पुट बिफोर यू. फॉरेस्ट कवर लॉस जो हमने पहले दिखाया था, उसी का स्लाइड यहाँ आ गया. व्हाट यू हैव 2001 से 2024 इंडिया लॉस्ट 2.3 million hectares of forest trees cover. We have already showed. This is again the forest cover loss that is connected with the earlier slide what I showed. Wildfire, logging, other natural disturbance की वजह से जो forest is getting cut, that is being reduced. That is a picture. Now say this one. This is a ground reality. The forest cut जो हो रहे हैं, you see these were the in earlier time. This is little bit valley part. This is Western Ghat, Kunur town. 41% decline in evergreen forest. and 60% fragmentation of continuous forest between 1973 to 2018. And the same state, ये internet picture इसमें data नहीं है, but it speaks volume. If you go to any hilly areas in north east, सिक्किम चले जाओ, गैंगटॉक चले जाओ, कहीं चले जाओ, कश्मीर की तरफ चले जाइए, लेह लद्दाख चले जाइए, उधर कम है. But what we have, the Western Ghat is one of the richest biodiversity region of the country, and that is being cut away. If you move from Bombay to Pune, Pune to Bombay, and that industrial corridor is being destroyed. It is being destroyed. So what we have, this is a picture that is imaged by Wikipedia commoners, that I have given. So this is state of affair, and this is what I said कि जब हमारे पास पैसे होते हैं तो हम सोचते हैं कि गर्मी की छुट्टियों में, समर वेकेशन में बीवी बच्चों को लेके जाएंगे, नैनीताल मसूरी में जाकर रहेंगे. पूना वाले लोग जाते हैं, बॉम्बे वाले जाते हैं, जाके इन एरियाज पे दे सेटल फॉर अ मंथ और टू. कोई बुराई नहीं, बट वी नीड टू थिंक ऑन दैट. नाउ द अनदर स्टेट ऑफ मसूरी, यहाँ मसूरी नैनीताल बहुत जाते हैं दिल्ली एनसीआर के लोग. से दिस वन, द स्लोप्स विच इज वेरी फ्रेजाइल. ये जितने फ्रेजाइल स्लोप है उस पर आप देखिए कंस्ट्रक्शन गोइंग ऑन. आप देखिए दे हैव गॉन टू द पीक, एंड द फॉरेस्ट कट एंड द फॉरेस्ट डिक्लाइन, एवरग्रीन और रिजर्व प्रोटेक्टेड, इवन प्रोटेक्टेड फॉरेस्ट भी बहुत सारी चीज कहीं कहीं चीजें इनक्रोच कर रहे हैं. तो इसको कट करके एंड देन दे आर मेकिंग देयर ओन settlement and houses. This is again image by Pinkani on this website that is on the net that you can see here. Now, major water related events. That is one aspect of it. Declining forest cover, green cover. Before that, I showed you some data on temperature change, precipitation and all. And then I showed you deforestation. Now, the major water related events in 2024. Very latest data what we have. Climate change significantly disturbed the global water cycle. On the very first day, Alex showed some water cycles, what they have done at the Columbia Climate Institute. So in that context, I put one slide, resulting in devastating water related disaster that caused 8,700 deaths, displaced 40 million people across the world. It led to economic losses exceeding 550 billion worldwide. Imagine, 550 billion worldwide, as per Global Water Monitor Report 2024. Right? Where all it has happened? You can take Brazil, major flood hit Rio Grande Sul, Amazon Basin. Then we have the USA hurricane, and Milton causes floods. Spain downpour, Central Europe, storm, Boris caused flooding. Afghanistan, then India, monsoon landslide, devastated Wayanad. Very recently, you all remember, Bangladesh, millions of flood affect millions of people. China, Yanzi, South Sudan, many more places. So if you go and see where all it is impacting, if you go on this own2earth.org, it's a very important website. Own to Earth, Mother Earth. हम बार बार कहते हैं मदर अर्थ, बट ओन टू अर्थ, वी ओन. ऐसा नहीं कि हम जिस जमीन पे मेरा घर नहीं है हम उसको ओन नहीं करते. आई ओन मदर अर्थ एंड मदर ओन वी. There was a very famous scholar, philosopher, Alan Campbell Churchill, and the very famous quote what he made: "Man is a product of earth, dust to dust." Isn't it? But we don't feel that. We do not feel that. हम अपने को अपना किसको मानते हैं? अपने बेटे बेटी को, बीवी हस्बैंड को मानेंगे, हस्बैंड बीवी को, वही अपने हैं जान, बाकी कोई अपने नहीं. But which is not so. We belong to a system, biodiversity system, where all should live in harmony. हम harmony में रहना नहीं चाहते हैं. And I go back to our own slide, earlier slide, कि हम जिस हिसाब से चाहें, जिस वे में चाहें, जिस रेट पे जाएं, we consume, produce, release effluents and what not, चाहे solid हो, liquid है या gaseous है, सारी चीजें हम जो है उसको रिलीज करते रहेंगे और हम उसको बहाते रहेंगे. See, rise in Himalayan landslide. Say this one. This is gone. Earlier it was lush green like this, but this is gone. Another part of the landslide is gone. Earlier it was lush green. That is a natural phenomena. Earthquake, landslide, debris flow, it keeps on going since the ages. That is nothing new. This is a natural process. There is a big but. What is that big but? With the increasing, economic activities, with changing nature of precipitation, temperature, all these are becoming very vulnerable. हम ही vulnerable नहीं हो रहे हैं, जमीन भी vulnerable होगी, पेड़ पौधे भी होंगे, जीव जंतु भी vulnerable होंगे, और उससे क्या होगा? लैंडस्लाइड है, उससे इम्पैक्ट होंगे लोगों को, सारी चीजें होगा. अदरवाइज रेट ऑफ लैंडस्लाइड, रेट ऑफ डिवास्टेशन कम होगा. And because of that, n number of problem what we are experiencing today is the resultant impact. आप कहते हैं ना कि वेस्टर्न डिस्टर्बेंस की वजह से बारिश यहाँ हो रही है, डिस्टर्बेंस वहां है, अफेक्ट यहाँ हो रहा है नहीं. एंड आईपीसीसी रिपोर्ट, फिफ्थ असेसमेंट रिपोर्ट कहता है कि ग्लोबल एवरेज टेम्परेचर has increased to 0.94 डिग्री सेंटीग्रेड. Isn't it? तो आई कैन से दैट 0.94 डिग्री सेंटीग्रेड डजंट मैटर. 1 डिग्री क्या फर्क पड़ता है? अभी 40 है, 41 हो जाए, 10 डिग्री 9 हो जाए, 4 है 5 हो जाए, कोई फर्क नहीं पड़ता. बट अगेन देयर इज अ बिग बट. व्हाट इज दैट बट? कि 1 डिग्री सेंटीग्रेड ग्लोबल एवरेज, अर्थ इज सो ह्यूज, उसका एवरेज निकालो फिर देखो, तो कहीं 10 डिग्री बढ़ा होगा, कहीं 5 डिग्री बढ़ा होगा, कहीं 5 डिग्री कम भी हुआ होगा. एंड एवरेज, दिस इज एवरेज फिगर, अगेन रेशियो फिगर, and that speaks volume. Isn't it? You want to say something? Okay. So average figure 0.94 डिग्री सेंटीग्रेड. और हमने इसके पहले दिखाया कि प्रोजेक्टेड, और एलेक्स भी दिखा रहे थे बहुत सारे स्लाइड्स में, and that was an important finding that has been done by top researchers to make you aware, to make the policy, make us aware, कि act and react in a way that it should not go more and more. And this is one issue. And the second important issue, what I always say, that it is nothing to be that, not much, do not get concerned much on the high temperature and all. This is erratic. That is more serious issue. The climate change is exactly erratic, and we do not know when it will happen. All the seasons have shifted. All seasons have shifted. जब बारिश होनी है नहीं होती है, जब होनी है, जब नहीं होनी तो होगी, या जब होनी होगी तो नहीं होगी. And there's a very pathetic situation. हमारे लिए कोई फर्क नहीं पड़ता. We are not dependent on the rain. But if you see, you talk about the farmers of any country, इंडिया हो, अफ्रीका हो, यूरोप के कोई, उनके लिए बहुत मायने रखता है. फार्मर बाहर निकलता है, आसमान को देखता है ना. And if I give one real example, जब हम लोग छोटे थे, पढ़ते थे, तो आप लोगों का, हम लोगों का एक बहुत इंपॉर्टेंट फेस्टिवल खिचड़ी कहलाता है. ईस्टर्न उत्तर प्रदेश, बलिया, आई बिलोंग टू बलिया, बहुत सारे पार्ट में खिचड़ी. जनवरी 1 से लेके 14 जनवरी तक सूर्य देवता नहीं दिखेंगे, और 15 तारीख को फिर वो दिख जाएंगे, है ना. एंड दैट वाज कोल्डेस्ट सीजन. अब वो खत्म हो गया. अब मुझे तो नहीं दिखता है कि साहब 1 जनवरी से 14 जनवरी दैट वाज सेम. वी हैव द मंथ सावन भादो, सारी चीजें जो, अब जिस वक्त सावन भादो में बहुत बारिश नहीं हो रही है, और जब होनी चाहिए नहीं हो रही है, जब नहीं होनी चाहिए हो रही है. सो दैट इज इम्पैक्टिंग द लार्जेस्ट सेक्शन ऑफ फार्मर्स, एंड दैट इज इम्पैक्टिंग इकोनॉमी. तो ये जो चीजें जो हुई है, दैट इज एक्चुअली क्लाइमेट चेंज. क्लाइमेट चेंज इज नॉट दैट कि टेम्परेचर बढ़ गया और ये मेल्ट हो गया, बट नेचर ने बनाया है. क्या बनाया है? कि किस सीजन में कौन सा फ्रूट हमें देना, भगवान अल्लाह ने बनाया. समर सीजन यू गेट लॉट ऑफ वाटरी फ्रूट्स, तरबूज है, खरबूज है, नाशपाती है ना. बनाया ना इसलिए कि जब आप जो है स्वेटिंग होती है, वाटर लॉस होता है, हम पानी होता पीते नहीं है, तो वो बनाया कि उसको आप यूज करो, एंड देन ये बैलेंस. अब वो चीजें हम सारे सीजन में सारे फल मिल जाते हैं, जो अच्छा नहीं है. सेब सुबह खाओ तो बहुत अच्छा है, रात को खाओ तो नहीं नुकसान है. यस प्लीज. नेम ऑफ, Oh, that is a कल इसको क्या कहते हैं, खिचड़ी, मकर संक्रांति. हाँ, मकर संक्रांति कॉमन वर्ड शॉर्ट में खिचड़ी कहा जाता है. तो वो अब खत्म हो गया, वो अब खत्म हो गया नहीं. लास्ट ईयर इफ रिमेंबर ठंड शुरू हुई, इट वाज इन सम टाइम इन जनवरी एंड सो दिसंबर में ठंडी नहीं हो रही है. सो ये जो नेचर बना है किस सीजन में कब बारिश चाहिए, कब कौन सा फसल होगा, दैट इज बीइंग इम्पैक्टेड. यस प्लीज. Yes. So the transition phase is also shrinking somewhere. Yes. So it's a diminishing transition period. So Basant and all spring season, the Baisakhi, they are also just somewhere. Yes. There are two issues. We have rightly pointed it out. One, I forgot to mention what is. One is that change in the timing, and second is the volume. We say that this much of volume rainfall has happened, right? But the volume has also changed. The volume has also changed. And say today we have very heavy downpour. So we do not need all water in a day. You grow a crop that needs some water at the growing season, at the mature time, and at the later stage. It is same like कि हम एक दिन खाना खा लें 4 दिन का तो नहीं चलेगा ना, थोड़ा थोड़ा चाहिए as per need. The farmer, they need water as per the time, different times पे कितना पानी चाहिए और किस तरह चाहिए. Very good crops, and then sudden rain, untimely rain is all washed away, it's gone. And that impact a lot on economy. So you do not look at how much rain has taken place, but important is that what is the temporal framework, at what time rain has taken place and how much. ये वैसे ही जब हम इकोनॉमिक्स की बात कर रहे हैं कि 6.2%, 6.4% इकोनॉमिक ग्रोथ है, बारिश नहीं, कहाँ से आया है, किस सेक्टर से आया है, और उस सेक्टर में कितने लोग इन्वॉल्व हैं, कितने लोग इम्पैक्ट कर रहा है, कितने लोग बेनिफिट कर रहा है. दैट इज वेरी इंपॉर्टेंट. एंड देयर द इशू कम्स इन स्पेसियो टेम्पोरल एस्पेक्ट, राइट. दूसरा देखिए साहब, लैंडस्लाइड का पिक्चर, नेट पिक्चर. हमने घर बना लिया फ्रेजाइल एरिया में, लैंडस्लाइड होगा, ऑब्वियसली विल बी इम्पैक्टेड. We do not look into the terrain. We do have understanding, but we still do that. We still do that. हमारे एक उस्ताद थे, हैं अभी भी, टचवुड, तो वो कहते हैं कि साहब, अतीक, we have not, हम नेचर ने हमको नुकसान नहीं पहुंचा, हमने नेचर के पास गए, ऐसी जगह जाए जो हमें उसका नुकसान पहुंचा. How? We have encroached on. We have gone in the areas, the habitat which is not meant for the human habitation. हम उनके एरिया में इंक्रोच किया हमने, और वो इम्पैक्ट करेगा. See the Europe and America, wildfires. Rich people, they have gone, नेचर के करीब, समुद्र के करीब, ओशन के करीब, वहां रहना शुरू कर. That is not our habitation. ये हमारा नहीं है, दूसरे जो है, जो नेचर के प्रजाति हैं, जो एनिमल्स हैं, उनके लिए है. So once we reach there, we get impacted. You talk about Yamuna, 12 kilometer Yamuna stretch crosses from north to south. दिल्ली को क्रॉस करते हुए नीचे जाता है. एक तरफ से ईस्टर्न उत्तर प्रदेश ईस्टर्न पार्ट है यमुना से इनक्रोच कर रहे हैं, और इधर से पुश कौन कर रहे हैं, दिल्ली के लोग. वी आर गोइंग इन द फ्लड प्लेन्स. और जब फ्लड आएगा कहेगा साहब इतना नुकसान हो गया, सरकार क्या कर रही है, मकान तो हम बना रहे हैं ना, हम क्यों गलत काम किया हमने, जो ना नेचुरल रिवर बेड है उस पर हमने इनक्रोच क्यों किया. दैट इज वेरी फ्रजाइल. और आज देखिए, जो इफ यू टॉक द पीपल, जो 40 साल पहले, 50 साल पहले, वी आर एट द बैंक ऑफ यमुना, यहाँ पे बहुत कम वो था बिल्ट अप सेटलमेंट, बट इफ यू गो टू कॉलोनी, कुछ बने जा रहे हैं. सो इट इज नॉट डन नेचुरल कैलेमिटी, इट इज कैलेमिटी दैट हैज बीन मेड, दैट हैज बीन क्रिएटेड बाय द ह्यूमंस for our own need and greed and need. That is important issue. तो आप देखिए सारी चीजें इम्पैक्ट हो रहे हैं. Now this fatal landslide in Himalayas in 2024. हिमालय में देखिए लैंडस्लाइड्स, ये सारे लैंडस्लाइड्स हैं. रेड पैचेस शोज सीवियर लैंडस्लाइड, येलो पैचेस एंड ग्रीन पैचेस दूसरे इंडस्ट्री शो कर ब्लू पैचेस. एंड वी ऑल नो दैट दिस इज अ बेल्ट, दिस इज हिमालयन बेल्ट, दैट इज Himalayan belt is, one of the youngest mountain, belt, but this is stable, quite stable. But we are encroaching and we are disturbing the entire, state of affairs. Human migration. Uh, Maybe in 10 minutes I'll move fast so that we can finish on time. Human migration. People have moved throughout the history for many reasons. ये हम जानते हैं और हमेशा मूवमेंट रहा है one reason or other. There are four forces that led to movement. One is conflict and um, uh, persecution. Second is natural hazard events. Third is cascading disaster and many other reasons. People choose to migrate temporarily or permanently. And in the current scenario, what we have, most of the migration across the world is, when you talk about the climate change induced migration, it is less, but political and conflict and wars is more. What we see in the Middle East, what we see in America, deportation by illegal people, yes, illegal people should go out. लेकिन वो हमारे यहाँ बांग्लादेशी बहुत आते हैं, नेपाली बहुत आते हैं, उनके यहाँ कुछ काम नहीं है, हमारे यहाँ आ जाते हैं. तो मोस्ट ऑफ द माइग्रेशन यूज्ड टू बी इकोनॉमिक रीजन होता है ना, अब चीजें थोड़ा सा चेंज हो रही हैं. दे शुड बी फोर्स आउट, उनको निकाल के बाहर करना चाहिए. In pursuit of better economic condition, what I was talking about. In other cases, government have pursued policies and program promoting movement of the population, relocating from high hazard exposed area to lesser hazard area. हिंदुस्तान में इतना it's not very it's not possible, but in this part of the world, it is possible that government do take care of कि भैया आप hazardous area में ना जाओ, यहाँ तो हम जाके बना लेते हैं, then we get impacted. There is a big issue. Human mobility, vulnerability and capacity is a complex interplay. In तीनों चीज है इस big interplay, mobility, vulnerability and capacity. Human mobility is age-old phenomena driven by numerous factors. That is search for better economics due to changing policies, combination of natural hazards and environmental degradation. It is a complex interplay between social, political, economic, cultural, and environmental factors. This has been added new. Earlier it was social, political, and economic. Culture is one. If you see this one, this figure, what we have, many factors influencing human mobility. Vulnerability, capacity, where the social, political, economic, culture is a complex interplay of all these factors. It is not just one. It is a complex factor which talks about the human mobility. Countries with high internal sudden onset disaster displacement number in 2016 and then climate change vulnerability readiness score. This is a score GIAN index, that is Notre Dame Global Adoption Initiative, which ranges from 0 to 100. Higher the value, more the vulnerability. See this one, Philippines, India, with a very high vulnerability to climate change. 50, 46, 50, Indonesia 50, India is 46, and then if you come to Colombia 56, and 2016 climate-related displacement. These are the numbers. This is the data for IDMC database 2017 and Cheng 2015. So that clearly shows that it is happening now, it is taking place, and that is a big issue. See this one, 10 largest displacement event in 2016 were climate related. As per IDMC database 2017, in India, 1,670,000 people were displaced because of flood in Bihar. Then you see other parts of Philippines, this much of people moved, displaced because of typhoon. You talk about China, Yangtze River, Typhoon Hama, and many more. So if we go on this site, you will find the state of affairs, the displacement due to climate related across the world, whatever interests you. Now, opportunities and challenges of human mobility, new economic activities, poverty reduction, increased wages, these are the opportunities. And if you go on the right side, what we have, a disrupted social network, labor exploitation, access to critical services, these are the challenges and these are the opportunities. So in India, if I say the migration and movement of the people, we teach you study in the population geography that people from the rural areas move to the not urban area, move to rural areas to a bigger rural areas, and from that bigger rural areas to small towns, and from small towns to bigger towns, and from bigger towns to further bigger towns like metropolitan cities like Delhi, Mumbai, Calcutta. And then from there we move to Gulf countries. And from Gulf countries we further move people, a large section of people move to westward. And that we call is step migration. That is step migration. It's not that people see there are two types of migration, economic reason जो हमारा हम पढ़ते थे. One is जिसके पास कोई नौकरी नहीं है, चलो जी ईस्ट वाले बम्बई जाते हैं, साउथ के लोग चेन्नई जाएंगे, कुछ वेस्ट वाले बॉम्बे जाएंगे, और इधर नॉर्थ वाले दिल्ली आएंगे, कुछ कलकत्ता जाएंगे. और कुछ लोग होते हैं फॉर बेटर गेन. दिल्ली में हम काम करते हैं, if I'm an executive in multinational company, I get 4 lakhs of rupees. Let us go to Dubai. वहाँ 15 लाख वेतन तनख्वाह है. You know, we move. And then from there, for better quality of life या attraction, we go to further westward. तो ये सारी चीजें, that is opportunities. It's not bad, it's good, but you know, when we are talking about migration, displacement, economic, now urbanization is rapidly increasing. I showed you statistics yesterday and today also कि urbanization, state of urbanization North America में क्या है, Asia में क्या है. In Asia it is faster. No, cities show that human mobility and climate are sustainable development issues. Human mobility and climate directly affect the sustainable development of cities. Human mobility and climate, what is it affects? It affects the sustainable development in cities. Better urban planning is key to produce climate risk. Cities must invest in reducing the vulnerability to those who move. You know? If you see this one, 13% of the urban population live less than 10 meters above sea level. There is another issue. There is another big issue that is coming up at a fast rate. What we are doing, global concern. Maybe I'll escape. There are a lot of discussion worldwide that has taken place. Say refugee convention, HIGO framework in action. Then we have global migration group, working group, human rights 2012. Then we have the Paris Agreement we talk about. Then global impact on migration 2018. No, many more. This is the four quadrant. One is the climate change drivers. You can see energy sector, industrial production, agriculture practices. Right side you see the climate effect changes, what all changes taking place. We have showed the statistics in data, accelerating cryospheric shrinking, what I showed the Arctic and Antarctic sea level rise, ocean acidification. Then we have the third quadrant is climate change mitigation. We need to have a mitigation capacity. We need to increase the mitigation capacity of the region, of the country. That is very important. Clean and renewable energy, carbon capture, storage, carbon pricing, many more. Sustainable agriculture, afforestation, green infrastructure, right? On the right side, what we have adaptation. Water harvesting, improving irrigation efficiency, restoring degraded ecosystem, afforestation, air forestry adaptation, crop diversification, building seawater. So now I'll sum up this slide, all 4 slides in one sentence in a way that what we have to do, we need to mitigate, we do mitigation activities and act less as compared to we add more to the drivers of climate change. You know, that is a side part of it. Maybe in a couple of minutes I'll try to finish it up. India's perspective on climate change. What India is doing. The government of India is very concerned since last so many decades. What we have, India focuses on balancing economic growth with environmental sustainability. This is very important statement. No? Acknowledging climate changes as a serious threat to threats while emphasizing the need of developing nation to achieve their developmental goals. We need to achieve our developmental goals. We need to provide the goods and services. But we need to balance economic growth with environmental sustainability. And that is a very crucial aspect of it. How to balance. How to balance. भूख भी लगी है और खाना भी खाना चाहते हैं और इतना खा लेते हैं कि साथ फिर वो नुकसान करने लगता है. You know, you get lot of आज हमारे, if you see the data, I do not know exactly if I give the vague idea कि जो obesity is a major problem rather than hunger. जो कम खाने से ज्यादा लोग नहीं मर रहे हैं, मर किससे ज्यादा लोग रहे हैं, डेथ ज्यादा हो रही है वो ज़्यादा खाने से, ज़्यादा खाने से, what we have, India has a pledge to reach net zero emission by 2070. 2070 is far away. We can achieve only by 2070 net zero emission अगर जो हम जो प्लान बनाए, जो पॉलिसी बनाए गवर्नमेंट ने, उस पर चले तो, अदरवाइज नहीं अचीव करेंगे. जब हम पढ़ते थे तो कहते थे हेल्थ फॉर ऑल बाय 2000, हेल्थ फॉर ऑल बाय 2000. अभी हम 2020 में, we have not achieved. We have achieved a lot in health sector, but still there are miles to go. So we need to work on net zero emission that has been, and set ambitious target for renewable energy capacity and emission reduction. Key aspect of India's approach: balancing growth with sustainability. The first line what I have. Then India prioritizes rapid economic growth as a means to improve living standard, adapt to climate change impact. Second is focus on renewable energy. India is rapidly expanding its renewable energy capacity, aiming for 500 gigawatts from non-fossil fuel sources by 2030, and seeking to meet 50% of energy needs on renewable energy by 2030. That is very important. Less of the countries, very less countries are trying to do this and focusing on this. It's not that they are not doing, but India is one of the leading country. We should acknowledge the effort of the government of India, of different ministries, be it climate change or petroleum ministry or whatever. What they are doing, focusing on renewable energy, emission intensity reduction. That India has pledged to reduce greenhouse gas emission intensity by 40% by 2030 compared to 2005 level. So these are the issue. What I wanted to say is that I also put more focus on India's and Indian regions. In the same way, we need to be concerned on our Indian scenario. Addressing climate finance, that's another important issue. Climate finance, from where the money will come. So climate finance, India has established a national adaptation fund and is working on mobilizing climate finance to support its mitigation and adoption effort. What we have, decoupling economic growth with emission. You need to separate it out. Economic growth with emission. India has demonstrated capacity to decouple its economic growth from emission, showcasing the potential for sustainable development. Emphasis on technology and innovation, clean technology, coal washing, reduce emission from the power sector and all. And if you see Delhi NCR, there were a couple of big power sector that has been closed. One was Badarpur, one was Indraprastha state that has been closed. And with that, lot of emission that has been reduced. So, and different state is also doing different, important work, public awareness and action. I feel that this is most important. And the sad part of it is that I say, with heavy heart that we all know, we are aware, but still we do not do that. That is a very sad part of it. We all know it's very sad to do such activity, but we do that. There are people who do not know. तो अवेयरनेस उनको चाहिए, लेकिन जो अवेयर है ऑलरेडी फिर भी नहीं कर रहे, तो उनका क्या इलाज है? Isn't it? That is one of the important issue. Recognizing climate change as a fundamental right, India's Supreme Court has recognized right to be free from adverse impact of climate change and as a fundamental right which can influence the future climate legislation. नवंबर दिसंबर में देखते हैं एनसीआर में लॉट ऑफ सांस लेना मुश्किल हो जाता है. सुप्रीम कोर्ट ने बहुत कहा है, गवर्नमेंट ने बहुत डायरेक्शन दिया है. स्टेट गवर्नमेंट ऑफ हरियाणा, पंजाब हैज गिवन वेरी स्ट्रिक्ट गाइडलाइन पनिशमेंट, बट किसान मानने को तैयार नहीं. अगेन इकोनॉमिक्स कम्स इनटू पिक्चर कि जल्दी से इसको फील्ड को तैयार कर लो और जल्दी से ग्रो कर दो ताकि हम क्रॉप को ग्रो कर पाए. मतलब देर नहीं, कोई बहुत जल्दी फास्टर मोड में, है ना, जो 1 महीने में अर्न करना वो 10 दिन में अर्न कर लो. एंड इफ यू टॉक अबाउट फाइनेंस की बात करें, हम बैंक की बात करें, तो बैंक एक इंटरेस्ट देता है 5%, 4%, 5.5%, 7% भी फिक्स एफडी पे. हम क्या करते हैं, बहुत सारे लोग, दैट इज वेरी सैड, कि हम किसी ऐसे इन्वेस्टमेंट में डाल देते हैं जो कहता है कि साहब हम 50% देंगे रिटर्न. कोई इकोनॉमिक्स नहीं कहता 50% रिटर्न देना इफ यू आर डूइंग ऑनेस्ट बिजनेस. लेकिन फिर भी बहुत सारे लोग वी गो एंड बिकॉज दैट यू लॉस. द सेम इज ट्रू हियर कि सुप्रीम कोर्ट कहता है कि साहब आप जो है इसको फंडामेंटल राइट है, लेकिन फंडामेंटल राइट एलेक्स वाज सेइंग कि हमारे लिए हम अच्छे से सोएं, आप उसका पोल्यूशन एमिशन हीट एसी का आप बर्दाश्त करो, आई डोंट केयर, है ना। कोर्ट ने ही रोका कि साहब आप जो जनरेटर्स हैं डीजल जनरेटर्स बंद हो गए, नहीं चलेंगे। तो फिर आए हमारे पास स्मोक फ्री एंड नॉइज फ्री, है ना। अब जनरेटर बड़े बड़े जनरेटर चलते नहीं पता चलता, अदरवाइज एक जनरेटर चलता तो पूरे मोहल्ला रात को उठ के बैठ जाएगा। लाइट गई, आप यू हैव मनी जनरेटर, आपने डंडी घुमाई एंड देन जनरेटर चला, यू गॉट बिजली, और बाकी सब लोग सो रहे हैं, दे उठ के बैठ गए। एल्डरली दो और सिक, वो परेशान हो गए। बच्चे जो पढ़ना चाह रहे हैं, बच्चे जो सो रहे हैं, उठ के बैठ गए, सो स्कूल जाना है, बट वी डू नॉट केयर फॉर दैट, isn't it? So that is very serious issue one need to understand, you know? तो ये जो मैं कह रहा था, पब्लिक अवेयरनेस की बात कर रहे हैं, सस्टेनेबल लाइफ स्टाइल एंड सस्टेनेबल कंजम्पशन। सस्टेनेबल लाइफ स्टाइल, हमें लग्जरी लाइफ स्टाइल चाहिए, है ना। अक्सर हम लोग जाते हैं कभी कलीग के साथ, गर्मी बहुत है, एसी चलाओ, मैंने कहा भाई बाहर नेचुरल एसी का हवा लो ना थोड़ा सा, नहीं साहब पसीना बहुत आ रहा है, कमान। इतनी गाड़ियां हैं जो मैंने दिखाया दिल्ली में, एंड दैट इमिट्स फॉसिल फ्यूल तो बढ़ नहीं कर रहे, सारी गाड़ी एसी। पहले बहुत एक गाड़ी में एसी होना एक लग्जरी हुआ करती थी, अब सारी छोटी गाड़ी हो बड़ी गाड़ी हो, एवरी कार हैज एयर कंडीशन, एसी नॉन एसी, एसी कार होना एक लग्जरी बहुत बड़ी बात मानी जाती है। दे आर एडिंग टू इट, एंड आई सेड यस्टरडे टेक्नोलॉजी इज रियल एनिमी टू क्लाइमेट चेंज। टेक्नोलॉजी इज गुड फॉर फॉर डेवलपमेंटल एक्टिविटीज, अच्छी चीजों के लिए, बट अगेन देयर इज बिग बट, वो टेक्नोलॉजी दिया, एयर कंडीशन कार में लगा दिया, हर जगह लगा दिया, फिर आप देखिए कूलर में अब नींद नहीं आती, पंखे में नींद नहीं आती। इवन इफ यू हैव अ कंफर्टेबल वेदर, बट स्टिल यू प्ले एयर कंडीशन। International cooperation, India's actively participate in international forums and collaboration to address climate change, advocating for a just and equitable transition. That is another very important issue that India makes. Traditionally, India has have been highly vulnerable to climate-related events like floods, drought, cyclone, many more. Many public-funded programs are there to address the direct impact of prevention and control. In addition to these main objectives of major poverty reduction, rural development program, reduction in vulnerability climate risk, India has spent about 13.35 lakhs crore, that is 13.35 trillion in just over 5.5% of its GDP on climate. That is very good. That is very good. So that shows clearly that India as a whole, the government is much concerned. One of the leading country which is more concerned about climate change as compared to the other countries across the world. There are different countries, they are feel concerned much more than others, but India is one of the leading countries which feel concerned. Probably this is the last slide. Annual central government expenditure to address climate change variability in 1997 to 98, it was 2%, little less than 2% of total expenditure what the government spent, but it has gone little up. See this one, expenditure on adoption of GDP, and this is expenditure on adoption of as a percent of total government expenditure. This has gone higher, it is close to 12. So that gives a very big hope, good hope to combat the climate change when we talk about Indian perspective. Thank you so much. We have some maybe we have some discussion, some observations, some comments, questions from audience, please. Yes, please.
Sir, I have some observations basically. So I'm not sure if I'm allowed to take a minute. I'll take a minute. So thank you so much for this intellectually stimulating presentation, sir. I want to bring it to the knowledge of this audience here that sir was invited in a lecture. It was a online lecture in an international seminar back in 2022 to Aligarh Muslim University. It was on the occasion of Earth Day in April 2022. There were international experts on the panel, and sir was the Indian expert. And I want to bring it to the knowledge that obviously you have seen sir's style of delivery of lecture. After the sir's lecture was over, throughout the lecture there was pin drop silence, and here the cohort is usually scientists from different PhD institutes, right? There in the university, it was a very heterogeneous audience. There were undergraduate students from arts, social science, and different theology and all faculties. The delivery style was so amazing that they could actually connect without having read a single research paper about what climate change is all about. So, and there was, sir, huge appreciation for you after you had, done your lecture. So my observations are a little bit, as I spoke the other day about per capita energy consumption. So the more focus should be on carbon footprint, as we talk about average American and an average Indian. The per capita energy consumption or carbon footprint is much higher for an average American as per Indian. But the gross, carbon emissions are more for India because we are we are most populous country. And the second observation, sir, is it's this has more to do with technology also today. As today we have YouTubers who are just promoting shopping halls and excessive consumerism. So austerity in consumption behavior is changing in terms of India. That's the downside of a technology if we don't take care of it. The second observation was about urban climate change and rural climate change, sir. In urban climate change, we all know what was the reason, but I was reading some article back in some days back where they were saying that rural climate change, there's also the disaster repercussions are seen in the rural areas as well. So is it directly linked to the domino effect of the urban climate change by and large, or is it just the rural?
Thank you for important observation, Ghazal. Kulsum, sorry. See, when you talk about the last point what you made, the effect on rural areas is impacted by the urbanization, and rural areas I see and say that rural areas are not the rural areas as of now. They are much more urbanized. You know, if you go to rural areas, you'll find many economic activities, many consumption pattern has slightly gone up. So rural areas are also fast urbanizing. You know, urbanizing in terms of consumption, in terms of expenditure, and so on and so. So that could be one that is being added apart from urbanization impact on effect on that. So these are the issue. And second issue, what you said, carbon footprint. Obviously, when you talk about the China and India, obviously the footprint is high. You know? But what we have, the consumption is higher in the West world. The footprint is also very high there. But India, because of the population, larger population, if we talk about, see, when you talk about a statistic, it will be different, and when you see the reality, it will be different. You know, again, I say the economic growth, very high, very good economic growth, one of the fastest growing economy, but the C standard of life, the standard of living, that is quite low. And we only talk about consumption in terms of food and many more things, but we do not. We should also look into the aspect of consumption of the health sector or education sector. You know, how much we consume, how much services we are having that is available. Yesterday we were having a discussion that after 40 kilometers we have one hospital. So that is also one important aspect that we need to understand. Thank you. Yes, please.
Thanks so much, sir. So I have an observation, not a question. So in that climate finance slide that you have mentioned it, so like the private companies and corporate sector, they have to make a report on ESG, environmental sustainability governance. So SEBI has mandated like 1,000 companies whose turnover turn 100 crores or something. There's a kind of a financial limit is there. So they have to make ESG report. That is a mandatory. So that is a part of the climate finance, and they have to invest in the climate adaptation activities and all that. So in crux, in nutshell, that I would say that ESG or CSR is also doing the part of climate change and all those things. Not education, other things are also there. So in a nutshell, private sector, corporate houses are also doing work in the field of climate change, as I am pursuing the sustainability management. So that's it.
Uh, Rightly said that the corporate sector is contributing. I missed it because of time, and I could not put the slide in statistics on that. I feel that those who all are producing, they should also look into their adaptation and mitigation measures. It's not that a corporate sector is big sector. Service sector is tertiary, quaternary sector is a big sector. So obviously, government has rightly made it. You have to take responsibility. Otherwise, nothing doing. You know? There's no free doing any business and do whatever as per your wishes. That's very important. Yes, please. The last question, if you want. Somebody else? Yes, please. Last point. We are running short of.
Thank you, sir, for your concise lecture. My question is, I'm taking an example of our neighbor China. There is a province, Yunnan province, where you can see a clear example of both city and an agrarian life going hand in hand. So, how can we implement how they do to our Indian economy? Because it is an agrarian one.
Agrarian, they're going hand in hand means?
Like without affecting nature, the infrastructure is also growing, and they are also having their own agrarian economy also.
See, what all we see and the statistics and presentation that has been done in last 2 days, what we see that the population migration, climate induced migration. So issue is that we act and react in a way that it should uh, hamper the natural cycle, mainly the rain water. So once you get the sufficient amount of water at your farmland, you'll engage yourself with there. Number one, and if you do not get sufficient rain, and you do not have money to get irrigation from paying some money, so obviously you look for some other option. So you'll move. This is one. Second issue is that when we talk about uh, uh, people move, because if we talk about India and other less developed countries, they move to the bigger another area for attraction. एक बहुत इंपॉर्टेंट है व्हेन वी टॉक अबाउट एनर्जी. गांव में बिजली नहीं आती है तो लोग सोचते हैं कि शहर में चलो. सो व्हाट वी हैव द कॉन्सेप्ट वी ऑल नो दैट प्रोवाइडिंग इंफ्रास्ट्रक्चर अर्बन इंफ्रास्ट्रक्चर इन रूरल एरियाज. So if you do that, and government is started thinking, and I'm sure that they are doing, they do that, they provide some infrastructure in a way that what they get it in the urban area, so they will not move. So though two issues that has to be managed. One is they should get the number one, they do not want to leave the agriculture, but they are forced to leave the agriculture because of climate change and lesser availability of water. Either take water and then they move. And so second is the government should provide something to them so that they should not move. Very common saying is that a person want to be in their own house with the family and the elderly mother and father, even if they are earning less. Say they are earning 10,000, they wish to be with their family. If he is getting an opportunity to earn 15,000 in another place in urban area, he say no, I do not want to be there. I'm happy with lesser money with my family, with my own township. So if we do that, then that balance can be maintained. What the China and other parts of the world are doing, right? So yeah, quick. We are.
Sir, it is a very eye-opening session. So I'll take one slide from yours, sir. So I'm a victim of the slide which you have shown the Western Ghats, the town of Kunnur. It is my hometown. So I'm belonging to that region. So I would like to share few points. I'm not going to take too much time. It is a break. So which is not current development. So during the British colonial period, it was being developed. The first thing is it has contribution towards to the World War as well. Second World War, Madras Regiment as still it is there, and I have mapped. It is part of my PhD study area region. So almost 80 percentage of the area is forest covered. So now it has been changed into tea cultivation. So due to that, there is a landslide, water scarcity problem. Everything it is happening in this small area, and this is an isolated town. So which is connected with the road network. So during my college days, during the heavy rainfall and landslide, this was the isolated. There is no transportation facilities, so it was stuck with a lot of difficulties. So another important thing is like a recent administration has taken effort of to conserve the natural resources and the plastic. It is the first district in southern India, so to ban the plastics. It is they have been made the check posts and they will check all the vehicles, been remove the water bottles, all plastic kind of things. This kind of government initiation also has been implemented. And one more point is it is there is no provision for construction of more than 2 or 3 storage building. It is banned. And groundwater extraction, no bore wells has been allowed in these regions. So this was the collective of informations which you can understand from this small region. So I was studying a lot in this. So rest of the free time you can discuss, we'll be share a lot of things. Thank you for the opportunity.
Very important ground reality you told, because you are from that place. So with this, we close this session. We have exceeded, say, 20 minutes from this first session. Alex, foreign expert, is sitting waiting. We have a short break, maybe for 10 minutes, and we have made arrangement for the tea here only because of the heavy rain outside. We are not in a position to go guest house. We'll have a break for the tea, short break. Maybe you can have biscuit and all and come back with the tea and sit here. Enjoy tea and listen the lecture of Alex. Thank you so much. And this is seventh lecture in a series that is on climate change, vulnerability, and risk mapping. I'm sure that in the last 2 days you must be highly benefited with the deliberation of the Alex. So I welcome Dr. Alex, and over to you, sir.
Okay, so one thing that I learned yesterday was, well, actually this morning, as I was having breakfast with some of the participants, is that some of you were actually looking forward to the index construction effort as a tutorial. And I chose to substitute yesterday the exercise that we all participated in, right? The causal mapping, which I hope you found useful and profitable. But I do have one more lecture that was supposed to be on urban-related risk and vulnerability on Friday. And what I'll do instead is use that as an opportunity. So I'll provide some data in advance tomorrow or even this evening, possibly, a very simple exercise in a simple index construction so that you can we can practice in class developing the index, okay? So I apologize that that's a little out of order in the sense that it's not in the order that we originally proposed, but I believe that it will still be fruitful. And I can't teach, everything that I normally teach about composite index construction in a 10-week course. Well, actually, it's a 14-week course at Columbia University, but I can give you some of the essential elements and point you to some useful reading on the subject so that if you need to develop your own indices in the future, you can rely on that material for future development. And today, actually, we'll be talking a bit about index development in the context of climate vulnerability and risk mapping. So you can, this is a teaser and a taste of what, you may be able to do after you complete this course. So I mentioned that I wrote my dissertation on mapping this concept of vulnerability. And we already know this because we talked about it, right? And then I mentioned about in the 1990s, there was this kind of awakening led by Susan Cutter, a professor at University of South Carolina, who has, by the way, had many students go on to do amazing things in this space. She developed this thing called the SOVI using census data. And I mentioned that the SOVI is now being used by FEMA, the Federal Emergency Management Agency, to guide their work. So we've talked about how indicators can in turn be combined with hazard, risk, climate, and exposure data. So you can take these social vulnerability indicators, combine them with data on hazard and risk and exposure, and begin to develop new insights into climate vulnerability. Furthermore, what we're going to talk about today is you don't have to be limited to solely working on the, admin 1, admin 2, or admin 0 data, admin 0 being state level, admin 1 being provincial or state level, admin 3 being generally, what's the name of it in district? What's below that again? I always forget. Tessel, thank you. I heard Tessel, thank you. In the U.S., it's census. We go from state to county, and then we go down below that. It's typically towns and villages. That kind of thing. Yeah, that's a district is a county, and in Spanish it's municipio. They call it. So the names vary. One reason why they came up with that convention of admin 0 down to admin 4 or even admin 5 is that, because the names vary around the world, you want to have some consistent nomenclature. So I did my thesis on the topic of climate hotspots. We're going to talk more about this systematic review today, and I better get my timer out because I'm going to, you know how I am. I tend to go on sometimes. I need to keep time. So let's get the timer out. All right, 1 hour and say 10 minutes. And let me add a couple zeros. So that's it. There we go. All right. And so, this idea of hotspots kind of led or, ultimately to my notion, my thinking was, well, if there's really extreme hotspots of climate vulnerability, then there's likely to be some kind of migration out of those areas. That was my thinking at the time. Now, and we'll talk about it more tomorrow, we know that there's actually much more to mobility than just people moving out. There's also immobility, and we'll talk about it. So let's look at first, before we go any further, what the critics say. Because there's always critics, right? It's social science. There's going to be critics. So Jochen Hinkel, he came up with the DIVA model. If you're familiar with that, it's a model that basically looks at coastal risk and coastal flooding. He did an excellent review article where he looked at indicators of vulnerability, and he critiqued the idea that we could actually measure or at least use indicators of vulnerability in certain ways. So he said, the various purposes for vulnerability indicators include things like identification of mitigation targets. So mitigation in this context, I think, meaning greenhouse gas reduction, not hazard mitigation. Identification of vulnerable people, communities, regions. Raising awareness of the issue of vulnerability. Allocation of adaptation funds. So in other words, instrumental use of the indicators to provide money to places that are more vulnerable, monitoring of adaptation policy, and conducting scientific research. He said the vulnerability indicators are only appropriate for addressing the second type of problem, but only at local scales when systems can be narrowly defined and inductive arguments can be built. Whew. Well, he set a very high bar for vulnerability indicators and basically said, it's all nonsense unless maybe you use indicators at a very local level and you're focusing on narrowly defined systems. I think that's a little bit too harsh, but it does beg the question, there's broader, and I do think that, frankly, that there's use of vulnerability indicators in more space than what he's described. But there is this idea that vulnerability indicators somehow can be used, as he says here, in allocation of adaptation funds. And so Richard Klein, who's used to be at least at the Stockholm Environment Institute, came along and said, well, basically, people want to know, ultimately, decision makers want to know which country is most vulnerable so that we can start shelling out funding so that they can do a better job. So think about the global loss and damage fund or the global climate fund. We want to send money to where it's most needed, and the best way to measure that is through indicators. And I've been involved in some of those kinds of efforts. I was actually working on something called the Transboundary Water Assessment Project, which was under the GEF, the Global Environmental Facility. and we were developing indicators of transboundary river basins. And ultimately, what we were told is that someone high up in the Jeff hierarchy wanted to have, or at least the board, the political representatives on the Jeff Council wanted to know like which transboundary basins were most vulnerable because they had a whole funding portfolio for transboundary river basins. Okay, so that was the idea. But what he says is that people working in this space are misguided if they think they can rely on external experts to develop a definitive, objective, and unchallengeable method to rank countries according to their vulnerability to climate change. There is no objectivist truth in vulnerability assessment. Any agreed approach will be a socially constructed outcome of a negotiation process. And this is, kind of harsh, also a little bit harsh language, aren't we objective scientists? Don't we wear white lab coats and, go and inspect things carefully? But I've already tried to convey that these concepts are inherently difficult to measure, and they're also subjective decisions that you have to make, and we'll talk about that today. Subjective decisions at each point in the construction of an index that ultimately you're subjective, you're going to make certain decisions. Based on your expertise. Having worked in the space of the Environmental Performance Index, so I've been working with Yale for 25 years on constructing global indices. These are country comparative indices. And often the critique we get, and I totally think it's justified, is you guys are a bunch of Westerners from high-income countries. What gives you the right to judge, and to actually develop these metrics? How can you say that they're purportedly objective metrics? And I think there's an element that's truth. There's, positionality is becoming an important concept in the social sciences. Just to say something parenthetically, positionality says where you sit and your viewpoint on life is fundamentally shaped by what your experiences have been and the privilege that you come from or the lack of privilege that you've had in your life. And so I just want to put that out there and acknowledge that that's a real issue. Finally, Berkman and Wisner, I think, take a slightly more pragmatic approach. So Johan Berkman was actually the author of one of the indices we'll be looking at. It's the World Risk Index. But they basically say, there's going to be a tension between complexity and mathematical parsimony. So the complexity is all the things that we've been talking about, livelihood and survival strategies, institutional and political power structures, etc., and the need for mathematical parsimony. The creative tension is between the need, in some cases, for a single number that expresses vulnerability and others for thick descriptions. This is Clifford Geertz was an anthropologist, and he had the idea of thick descriptions, meaning you go in and you sit with a community and you develop what's called an emic perspective on their community. That means you're looking at it from within, almost like the inside, rather than the edic view, which was from the outside. And so, we want to be able to get to that thick description in some cases, but there's also a need and there's also a demand, frankly. I've seen the demand for indices. So I'll be talking about some of that demand as we go along here. So what are some of the country level indices out there? I already mentioned they can be used to prioritize funding. They can communicate risk. Some assess current risk. Some use climate projections to anticipate risk. Here's a disaster risk index. It's backward looking. It's a little bit dated now, but it's was out there, was developed by UNEP Grid in Geneva. And basically they looked at, deaths. It was an outcome measure, essentially, deaths from different disasters. And I'll just say also parenthetically that a lot of these analyses rely on MDAT, which is the MDAT is the Epidemiology of Disasters database. It's based out of Liège, Belgium. Have any of you used MDAT at all? Do you know about it? Okay, it's basically, it's the longest standing database on disaster outcomes, so displacement, deaths, other things. And they collect using media reports, they collect using official data from government agencies and from UN reports. But, the truth is it's very hard in the aftermath of a natural disaster. You notice the numbers are always round numbers, 15,000, 20,000, whatever. They're never like 19,998 You know, so just to say that, you know, the reason they're rounded is because they don't have a precise idea of how many people were affected. Anyway, so they use these data to develop this, and you can kind of see the patterns. You know, India, Bangladesh, South Asia in general, with high disaster risk according to this index. Then you go to something called the GIAN. This was developed by Notre Dame, I guess we call it in America. And that's a university in Indiana. And they came up with this index that looks at, you know, the various elements we've already discussed that go into vulnerability. And then they have a readiness component as well. Let's drill down and look at what's in the vulnerability indicators. So they have food, including projected food. So each of these, you'll notice, is broken down into exposure, sensitivity, and adaptive capacity. So all that background that you had on the first day is helpful now in understanding how they break down their index. So let's just take health. They say exposure, projected change in deaths from climate change-induced disasters. Probably a lot of questions about how they do that. It's not a trivial matter to project that. So they would want to have metadata and documentation showing how they do that or what the source is. Slum population is a sensitivity component, and medical staff is the kind of adaptive capacity. But each of these has those components associated with it. So they're doing a massive data compilation and ultimately data reduction effort. Then on the readiness index, we have things like, and these are using the same exposure, sensitivity, and adaptive capacity categories. So you have governance, political stability and nonviolence, sensitivity is control of corruption, rule of law, and then lastly, regulatory quality, like the quality of the regulations in place, the policies. So this gives you an idea of what goes into this index. And these are some of the latest rankings. They update this periodically. I pulled this from the website this morning, so these are the latest rankings. The map that I showed earlier may or may not reflect the latest version of it. You know, fairly typically, high-income countries come out being very they have a capacity to adapt. India is here in the lower middle rankings, essentially, ranked 115. And you know, Sri Lanka is just above it, and Iraq is just below it. I don't know how they come up with Libya being, you know, anywhere near 117. I think it's a failed state as far as I can tell, so that would suggest to me that it should be further down on the list. But you'd have to look at the individual indicators and the data sources they use to get better understanding of that. So this is turning to the project that I mentioned Johan Berkman has been involved in, called the World Risk Index. You know, you'll notice that the map doesn't, you know, the map is very similar to the map that you saw with the GIAN index, but the framing is different. So here you see, you know, it's more of the IPCC risk framing from the AR5 and the special report on extremes. Climate extremes. Exposure is on the outside here, and it's like an army tank connected to in a production line with vulnerability. So like army tank treads or something, and or maybe gears in a machine. And you can then rank countries according to this measure of exposure in relation to the vulnerability, which they break down into susceptibility, likelihood of suffering harm, coping. I like the fact that they break out coping a little bit more, so I think there's elements where you can learn about what these concepts mean by looking at some of these things. Here you can see what they talk about in terms of coping capacities, and this is what's already in place versus, I think, adaptive capacity is more like what they can do, what a society is able to do and what it's able to plan for in the long term, and in terms of and its kind of education systems and other. These are really investments that are made for the future, whereas this is really like what's in place now if disaster strikes, if you get that sense. And then they have a bunch of susceptibility indicators related to, you know, public infrastructure, nutrition, poverty, dependencies, et cetera. And these are the hazards that they look at. And so you can see how they look at the exposure of the population divided by the total population. On the one hand, over here, you can see the weighting, so it's all very transparent. And then they basically add to that the susceptibility, the coping. And so this isn't what we call an additive. I think it's an additive model. I'd have to double check the math that they display in the report. One thing that you'll notice, though, is if you start looking at the correlation, again, this is an earlier version of the Global Adaptation Index, but I don't imagine it's changed tremendously. If you look at the correlation with GDP, it's pretty high, right? So you could almost say, you know, at a 0.8 correlation, if you look at GDP, you're basically looking at adaptive capacity. The value, though, could be that in looking at the deviations from the trend line, countries that are on the upper side of this are basically doing better for a given level of GDP than you might otherwise expect. And the ones on the below, like Angola, Qatar, Chad, are doing worse than you would expect for their GDP level. So that's a way of thinking about it. The scatter is a little greater when you look at the World Risk Index. And you know, one of the things that's obvious is that some countries, because this has a very heavy emphasis on the exposure element, some countries like the Philippines, Guatemala, Bangladesh, Papua New Guinea, these are countries, Chile, that have very high levels of exposure, and that can be, you know, the case whether you have a high or low GDP. So that's one reason why I think this one has more scatter around the line. I see some puzzled looks. Everybody getting what we're doing here? All right. So issues with country level indices. Again, more critics, and I think they're also valuable. This is an article that basically took issue with an index called the Environmental Vulnerability Index that was developed by SOPAC, which is a group in the South Pacific, and they were looking at small island states. The lead authors from Australia, and they often tend to think that the South Pacific is kind of their research domain. So they basically said, we conclude that indices of vulnerability to environmental change cannot hope to be meaningful when applied to large-scale systems, and so we should focus on smaller scales of analysis. So that's interesting. They conclude somewhat similar to what Hinkle said, is you can't really do this at a country level. You need to do it at a much more granular level. So let's look at some granular level efforts. These are starting to get down below the national level, but not necessarily down to grid cells yet. So let's look at that. So what is the purpose? These are meant to show where the hotspots are again, describing the nature of the stressors in the most vulnerable areas, to help design responses. People want to know where to anticipate, future disaster or hazards so that they can anticipate response needs. They, as I mentioned, they're used to prioritize and target funding. And then I would just say that there's a lot of academic interest in this area. And even though Hinkle said that, frankly, it's not a useful research endeavor, hey, we're academics. We're going to do it anyway. Sorry, that's just who we are. We want to develop new approaches. So let's look at SOVI and INFORM as two approaches. And again, when we do that exercise on Friday, we'll have a chance to get the data, get our hands into the data, and start looking at these things a little bit more and see what some of the issues are when you start putting data together. I may even give you a homework assignment beforehand if I'm able to prepare and enough. I'll get you some data ahead of time, and you can start playing with the data a little bit yourself. But this is what the SOVI includes, and I mentioned the SOVI earlier when I talked about the Mumbai and the New York City comparative effort. And so I conducted a SOVI in both cases, the difference being that I had different data sets available to me, so I couldn't necessarily measure the same things. And so you've got, Susan Cutter's SOVI over here, and you've got what became a federal government effort under the Center for Disease Control in the U.S. to measure SOVI. They actually just took it offline at the beginning of the Trump administration. They said, we don't want to know about social vulnerability. So that's an interesting political response. But what we did, the data is still available, in part because we have all the data available through a gridded version that we produced. One of the advantages of the gridded version is you can see that it eliminates areas that are not actually populated. So there's no SOVI where there's no people. And you can use that instead. But you can see the kind of variables that they're looking at in the construction of the what they call the SVI rather than the SOVI. And so it's a useful metric, and we've used it a lot in research at our center. I've also mentioned yesterday that working with a woman named Beth Tellman, who was a former postdoc at Columbia University, is now at Arizona. We worked on a paper to look at whether outcome measures of the SOVI, like when you look at deaths and you look at damage to buildings and damage to infrastructure, does the SOVI actually help predict, which it should, in theory, help predict how many deaths occur in light of natural disasters? And so that's a paper. I could try to present some results of that later, just to show that it is an important element, is to do that validation against outcome measures. So this is an example of something I was involved in a few years ago where we went, again, under USAID funding. And the project was called WABIC, West Africa Biodiversity and Climate Change. And the WABIC project basically was interested in mangrove preservation in two countries, Cote d'Ivoire and Sierra Leone. So we conducted a very in-depth, well, I call it pretty in-depth, social vulnerability exercise, doing primary data collection in villages up and down the coast of Sierra Leone. Sierra Leone is between Guinea and Liberia, and it's sort of south of Senegal and all those countries to the north. And so what we did was looked at across, so first of all, let's just look at the characteristics of the sample, the communities that we were looking at. And the characteristics included things like fishing wild fish, processing fish. These are the livelihoods that people had. Small businesses, so you might have a little shop and you'd sell some water, canned, maybe some tins of sardines and batteries and things like that. So that might be a small business. Subsistence agriculture was also important. And these are just measured by the percentage of households involved versus the importance, meaning the amount of income that they got from different things. So you can see here that fishing wild fish was fundamentally the most important thing for these coastal communities living in mangroves. And so what we did is we used a bunch of indicators. This is exposure levels to different environmental stressors. And you can see in the north, high exposure, a lot of red, and then it starts to decline a bit. And that's partly because in this northern area, the mangroves had been largely stripped clear and rice agriculture had been put in place of the mangroves. So there was no longer that buffer to flooding, to storm surge, to major climate-related events. And there were also fire risks associated with some of the villages because when you're doing fish smoking, you're doing it with fire. If the wind kicks up heavily, that fire can get out of control, burn your fish shack where you're smoking your fish, and then it also will result in potentially burning your own home. So there were a number of things in the north that were more prevalent. Adaptive capacity, we also measured using a number of different metrics. These are all available in this report. And then finally, what's the next one? This is the total vulnerability score. The main point of this, not to get into too much detail, is to say that you can go down to the local level and collect data, and many of you, I think, want to do this kind of thing, right? You want to go in and do a participatory assessment, or some of you do. I see one person nodding. And so, you know, you can go and collect that data. So this would be a very good guide to kind of how to go about doing that, because we give a complete survey questionnaire. We give everything by way of documentation of what we did. And we tried to follow the best practices. Overall vulnerability of households by quintiles. And so we found, for one thing, there's more vulnerability down in the red areas down here, partly because the communities are poorer also. So even though these communities, they have pretty high vulnerability, some of them, but the reality is that they're actually more prosperous in part because of the rice cultivation. And then if you look at this, which I thought was a useful way of summarizing some information about how much, this was a participatory research effort where we basically looked at how frequently people worried about different things and how important they deem those things to be. And so, you know, you can imagine a PRA exercise or focus group exercise where people are putting they're given a pot of like 10 beans or something, and they say, well, I'm really worried about this, but I'm less worried about that. And so they put 5 beans in the food category and 3 beans in the in education category or something, but then they don't have any beans left, so they don't put anything in the other categories. But basically, you can see most of these things are stuff that a lot of people in rural areas of the developing world would be concerned about and have high concern about: money, education, food, housing, shelter, health. These were all high incidents. In terms of importance, they had issues around not having access to markets, government aid. The transport infrastructure in this area is very poor. These are very isolated villages. And then you can see things specific to fishing communities like outboard engines and fishing materials. Where does environment come in? Kind of little dot right here. And also flooding. You say, how can that be? These communities are living at water's edge. The water is actually going into their houses at the rainy season. Flooding doesn't matter. Why do you think? Tell me. Yeah. They live in the water. They're always got water. It's been every year since they were children they had water coming into their house. Do you think they're going to worry about it? No, it's part of life. All right. Now switching dramatically to the global scale, like going from village to local. I led an effort at CESN, our center, to develop this index. We now have a version 1.10, which has been released. Well, if you want it, come to me and I'll get it to you, okay? It's a global grid. It corrects some issues. The new version corrects some issues that I noted were affecting a kind of overestimate well, we were saying that there's almost no deprivation in certain parts of urban areas of the developing world, and so we kind of corrected some parameters. This is a little bit the subjective aspect of index construction, right? I said there's no way that being in the center of Nairobi is equivalent to being in a rural area of like Tennessee or New York State. It's qualitatively different. I know there's wealth in Nairobi, that's not it, but I kind of realized that the numbers were not quite, they shouldn't, by exploring the data more fully, we found that they weren't useful. There were issues with the overestimate of kind of what I would call resilience in these urban areas. But what we did is we just basically did a mashup of a lot of subnational data that we had available to us, from subnational HDIs all the way down to satellite data at the bottom here. And then we also removed the slope in nighttime lights, which was meant to detect whether places were getting brighter or they were getting dimmer. If they're getting brighter, in theory, your deprivation levels are going down. But we found that they were so highly correlated with the overall luminosity, the actual nighttime lights, that they weren't really a useful addition. And in some parts of the world, like Europe, they were developing new lighting technologies and they were going down because of the new lighting technologies. So you have to look at those sorts of things when you do anything on a global scale. So we just removed the slope in nighttime lights in the new version. I don't have a map of it here. I can get it to you if you want, but it does correct some issues that we discovered. Anyway, it's a useful index, and one of the things I mentioned yesterday was that a colleague who does catastrophe modeling said that his catastrophe models do a better job of predicting damages when you include this data set. Well, the new version of the data set, not this version, but the 1.10 version, it actually does a better job of predicting damages. Finally, you can downscale and project future vulnerability. This was an effort led by a colleague, a PhD student who came to visit me from Italy. He's at the Euro-Mediterranean Center for Climate Change Research. And so he visited us this spring, and he wanted to project the Informed Climate Change Index to 2050 for Ethiopia. So we wanted to look at the Inform Index. If you're not familiar with the Inform Index, I don't have time to go into all the elements, but his particular interest was in this climate change index. I will just say that the Inform Index has some of the same rationales and background as the other ones, the World Risk Index. It's got more institutional backing. So the GIAN and the World Risk Index are kind of one group going ahead and producing something. This one actually is funded by UN OSHA and carried out by the UN, the JRC and ISPRA, and they do great work, and they also have a lot of other coalition members. So this is the Informed Climate Change Index, Risk Index, and again, you see hazard and exposure, vulnerability, and adaptive capacity. So nobody's kind of reinventing the wheel completely in any of this work, but you've got all these different variables, and these are the variables that my colleague Domenico, I'll call him Domenico, his last name is Bovienzo, he was interested in. And he explicitly adopted the SSP framework that I mentioned earlier to project these variables into the future. So he used two as bookends, as it were, between the sustainability and the regional rivalry, which is kind of what many view as a worst case scenario in the future with both high challenges to mitigation and high challenges to adaptation. So the two variables that he was particularly interested in working on when he came to visit with me was projections of vulnerable uprooted people and vulnerability groups. So he used data that we had produced in the Africa Climate Mobility Initiative to find out what the future migration flows would be under these two scenarios into certain areas of Ethiopia. He looked at population projections, which we also have via the NASA CDAC I mentioned yesterday. He looked at food insecurity projections using crop models and existing data from the what they call the Living Standard Measurement Survey in Ethiopia. The World Bank conducts these LSMS surveys periodically, and basically he was interested in understanding how food security would change in the future based on various climate projections, and he also found data on Human Development Index projections, and then he came up with this overall climate risk index change. So this is the baseline with much higher vulnerability in eastern Ethiopia because it's largely dryland, pastoralist area, and a little less vulnerability, or whatever they're calling it. I think it is risk, sorry. So the risk is lower in the highlands in the west, but they basically had found that certain areas in particular, this, which is a low-lying, very flood-prone area on the border with Sudan, had very different changes in risk based on whether you take a sustainability approach and think about things being much more sustainable in the future, so great declines in risk, versus a high-risk scenario where there's greatly increased risk. And again, he also used I didn't mention this, but he used future projections of flood risk and drought risk and things like that from a physical science climate basis. So that's all factored into this effort. All right, so that's covering. Let's just take a look at the time. So I have 37 minutes remaining. So let's go through this part. I'm not going to take a lot of time to go through this because it's a little bit dated, but there have been a number of efforts subsequently that borrow these methods. So UNEP at a certain point had these global risk reports, And they have been essentially adopted a methodology very similar to what we did for this World Bank report. I say we because CSUN was one of the major contributors and data processors for this. And the idea behind the risk is solely to focus on that hazard component. You know, remember I said hazard, exposure, and vulnerability makes up the new framework. Well, at that time, there was an interest in just looking at the hazards. So the purpose, like I've mentioned many times now, is to prioritize more. One idea was if we do this global assessment, we can prioritize more localized vulnerability assessments to identify the highest risk areas within countries, and also a demonstration effect. And because we're scientists, we like to do cool things with data, right? So they had at the time a much different array of data that were available at the time that they did this. I say they because I wasn't directly involved, but colleagues were. And so at the time, there weren't a lot of data available on some of these parameters, and some of them were quite coarse. So let's take a look. The coarseness is, you know, 1 minute, 1 degree for floods, which is extremely coarse. Subsequent efforts have managed to do a much better job of modeling flood risk. So this is an example of some of the outputs, just to give you an idea. So highest, this is single hazard, just cyclones. Gee whiz, cyclones occur in certain parts of the world. They're very localized, and they happen because of the production of cyclogenesis. And that's a whole science unto itself. It's differences in atmospheric temperature. You start getting a gyre going, and then suddenly that gyre goes all the way from the coast of Africa and hits the Carolinas or somewhere in the US. So the red areas have the highest risk decile. I wouldn't put too much credence in the drought work because it was a very coarse resolution, but you get a general sense. Remember I talked about Hadley cells in that first lecture on climate, third lecture on climate. Well, these red areas are all essentially adjacent to where the Hadley cells are important climate predictors. Flood risk, again, very coarse resolution, but you get a general idea that Asia, South Asia, or at least the Himalaya region and the Bangladesh, Ganges basin are all very high flood risk areas. Earthquakes, again, limited to areas where earthquake activity, the Ring of Fire around the Pacific and such like. And then volcanoes, very limited in terms of their spatial extent. And finally, landslides, again, restricted to mountainous areas. And then what you can do, what was kind of cool about this effort, is you can look at the highest risk deciles layered on top of each other. So the top 10th percentile of every risk, and just layer it on top of each other. And so these are, top 3 deciles exposed to drought only, but then you go down here and you see seismic and hydro, drought and seismic, drought and hydro, drought, hydro, and seismic combined. So you get these areas that are like multiple risk. And of course, India and the Gangetic Plain and the Himalaya region have pop out. And finally, you can just look, like I mentioned, take the highest of all of them. In the red areas are 3 to 5 hazards combined. So you see these areas highlighted here. The Philippines, I'd say Nepal, Bangladesh to some extent, Myanmar, these are really high-risk areas. They also combine the data on hazard risk with MDAT data. I just mentioned MDAT. So using MDAT, they could imply or deduce the level of mortality resulting from different different hazards. And so what you see is for cyclones, droughts, earthquakes, floods, landslides, and volcanoes, for Africa and East Asia and the Pacific, you can see different mortality rates per 100,000 in the year 2000. And low income Africa has, really off the charts risk for drought, for instance. But you also get for East Asia and the Pacific high mortality for cyclones. And then these are mortality. So these are not what we were seeing earlier, not the incidence, but the actual mortality results. But you see areas that have risk of mortality from different, at high level from different things. Now here's economic losses. What's the difference between this map and this map? Do you notice anything? So this is the mortality one. This is economic losses. Everything shifts up, right? Shifts to higher income countries because your economic losses invariably are going to be a function of how much you have exposed. And if you have a lot of assets, a hurricane hitting Miami is not the same as a hurricane hitting Maputo, in Mozambique. So that's going to see a lot more loss in Miami. And then what you can do is normalize losses by GDP, and then you get a better, more equal, let's say a more clear, apples to apple comparison. And there you see a lot of economic losses in the Gulf region, Northern Gulf, Iran, etc. Okay, finally, just to say that was not the last word, it was just the first word on this work. Then there were, I think it was Provia, I can't remember, Prevention. The Prevention Consortium was under UNEP, and the Prevention Consortium developed higher, more high-resolution versions of the data that I just described and went on to refine the work in various ways. And this is just the most recent effort. It was published, I'm sorry, I didn't write the publication date down here, but I think it was in the last 2 or 3 years. This is an example of one of the data sets that we use for that CASA assessment of urban vulnerability. So remember, I went through during the urbanization session results for that USAID funded assessment of different parts of the world. And you can see that people are continuing to develop hazard mapping. So this is really the meat of what I want to talk about today. And I have 30 minutes. So I'm going to use an example of work we did in Mali. And the Mali work was funded by USAID under a project called the Africa Resilience to Climate Change Project, and or ARC, ARCC. So just as a sort of, again, why do we do this? Mapping can illuminate key vulnerabilities in the coupled human environment system and in turn inform where adaptation may be required. Mapping will not necessarily tell you what needs to be done now to build resilience. So I think you just have to be careful about understanding the value of mapping, what you can do with it. But to do the actual, like, what should we do? You need to go to the ground and you need to talk to people. There's no escaping that. So this was, fundamentally a desk exercise, where we had data from a variety of different sources that, again, followed, in this case, the earlier IPCC framework, vulnerability framework, where the overall vulnerability was a function of exposure, sensitivity, and adaptive capacity. And we had a variety. Well, we worked with climate scientists, so I just want to say up front, if you want to undertake this kind of thing in your own, here in India, I would say you'd be very wise to work with subject matter experts in different domains, and particularly in the climate domain, you want to work with people who know how to work with climate data and not simply come up with stuff on your own, thinking that you can kind of figure it out on your own. So for instance, one area that was considered to be important that I wouldn't have included by a colleague who has worked extensively in West Africa. She was the one who led the vulnerability assessment in Sierra Leone, by the way. Her name is Sylvia. And Sylvia Traska is her last name. Sylvia Traska, somewhere maybe, Sylvia Traska listed here. She's kind of an unusual person. She's sort of a geographer. She's really a hardcore climate scientist, but she also studied geography in France. And I was stunned by her ability to carry out a vulnerability assessment in Sierra Leone, given that her core competency is climate science. Like, that's what she's really known for. So that's just an aside. So some people surprise you sometimes, right? So anyway, the percent of precipitation variance explained by decadal component in West Africa is very important because there's something called the decadal oscillation in climate. And so that decadal oscillation actually, you know, the great Sahelian droughts occurred about a decade apart, right? 1970s, mid-1970s and mid-1980s. I was there for the second round in 1983, well, right around 1984. And those Sahelian droughts, excuse me, were a function in part of this decadal oscillation in precipitation. But you know, there was just some basic ones that you might think about yourself: average annual precipitation, the interannual coefficient and variation in precipitation. So how much is your rainfall varying year on year? All these data were, you know, in the most part, the climate data were all gridded. We had long-term changes in temperature, and flood frequency was another factor. Then we had these sensitivity and adaptive capacity. So remember, I mentioned long-term kind of capabilities to respond, things like education of mothers, market accessibility, so road infrastructure related to markets and things, health infrastructure. We use something called anthropogenic biomes, and I'll talk about it in a moment, but you'll see a map of it in a moment. But basically, one of the things I was concerned about, knowing a little bit about Mali, was there's a whole area in the middle of Mali that you would predict to be very dry and very arid and not productive. But it's actually called the inland delta of Mali. So the Niger Delta, the Niger River flows, and during the flooding period in the middle of the monsoon, it actually goes out and braids, and it goes braided for quite some distance and creates a huge floodplain in the middle of Mali. So this is something we wanted to capture, and I'll show you that in the anthropogenic biomes data, irrigated areas. And then we had these sort of sensitivity measures, which are mostly outcome measures like poverty, child stunting, household wealth, et cetera. We also had something on malaria. So let's take a look at this. There was some interest, and I published an article. I think it may be among the articles that was listed on the last day of the course this week. It's an article that looks at physical variables from remote sensing data and their application in this vulnerability mapping work. And so this is an example of you know, if you looked at this here, coefficient of variation in precipitation, you get 5 like half-degree grid cells, right? You wouldn't be able to distinguish that much between different areas. So what I wanted to do is get something higher resolution. And one way of looking at, whoops, this thing stopped. I just need to have Rahul touch it, and then it'll be good. And feel free to advance it to the next slide while you're working on that if it's... So you think it's working now? Okay, great. Thank you. You touched it. So the interannual variation in greenness, which is some of you know is the NDVI, those of you remote sensing experts out there, was one way of doing that, where you could see how variations in greenness are lower in the south where there's higher rainfall. Then they get very high in the Sahel, upper Sahel, and even into the Sahara region. Then they're low up here. Why are they so low up in the north? Can someone tell me? Does anyone know what's up here? Is it raining again? No, it's the Sahara Desert. So there's no variability in greenness because there's no greenness to start with. Just a trick question, sorry. So one of the reasons why we cut off Mali at about this latitude was we didn't want to include parts of the extreme desert regions that if you had those in there in your index construction, you'd get extreme values for just about every variable. And we just wanted to avoid that. So we cut off Mali. I think it's, I don't remember what latitude, maybe 17 degrees north. And then we had flood risk, which was a higher resolution version of the flood risk data I described earlier, based on some more recent analysis that was done. And so you see the inland delta showing up here where the floods occur frequently. And then we had other data from remote sensing, including soil carbon. So much higher soil carbon in the southern parts of the country. And then for each variable, and this is very important in index construction, you just need to be transparent how you do this. But you have high to low precipitation. So this was really low in the north and very high, relatively speaking, in the south. So you have to create some transfer function, essentially, where you take the native values in millimeters and transfer them to a unitless scale, 0 to 100. And in our case, 0 represented the lowest vulnerability, and red, or 100, was the highest. So in this case, we had to invert the scale, right? Precip's high, that's good. That's bad for, precip high is good for vulnerability, and precip low is bad for vulnerability, and so we just inverted the scale. I'm going to confuse myself here. Transformations to a common unitless scale. That's what I was trying to get across. Other transformations that you see are what I mentioned earlier, the greenness, variation in greenness. So you see the high variability in that Sahel zone. And then I mentioned 17 degrees. I was close. It was 17.2 degrees north latitude. And one of the things that we tried to do very carefully in our final report was look at the variation, so provide histograms of the variation of the raw data, and then show that in some cases we did what's called winsorizing, or trimming the tails. So you have this very long tail where there's this coefficient of variation that's like way up at like 0.8, 0.7, and we wanted to trim that. So we simply said anything higher than 0.5, if it has a higher value than that, we bring it back down to like 0.5. Does that make sense? And then we rescaled everything on the 0 to 100 scale. Not quite normal distribution. And this is where you might get into things like if you had a skewed distribution, you might want to log it or something of that sort. I don't think in this work we actually logged too many of the variables, if any. But all of that is in the metadata, and I'll get to the metadata in a moment. These are climatic data, gives you an idea of the precipitation, long-term trend in temperature. So temperatures are getting much hotter up here. Does anyone know why that is? Some of you physical scientists? Closer to the desert. Drier areas, the ground heats more, there's less evapotranspiration, right? So all those things lead to hotter, like it's going to get hot. If temperatures overall are getting hotter, it's going to get hotter in drylands than it will in more moist areas. This is the flood remote sensing of NDVI I mentioned earlier. Flood extent, again, transformed. So you have very high flood risk in some of these areas along the Niger River. Anthropogenic biomes I mentioned earlier. One reason I wanted to include it is because it includes rice growing regions in the Niger Delta. Those would be lower vulnerability because we just coded them in a certain way. Yeah, you have a question? Yeah, it's gridded. Yeah. This was from Chirts, CHIRTS. Some of you are familiar with it. We interpolated. Yeah, I'm going to show you how we did some of that in a bit. Like some of it wasn't gridded, right? Some of it was based on admin 2 or admin 3 level data. Some of it was based on point data. So I'm going to talk a little bit about that in a minute. Just to give you quick headline results, this is the exposure, very close, very clear south to north gradient based on rain, mainly on precipitation, but also variability in precipitation and flooding and things. Sensitivity, you can see, is a kind of goes out from Bamako, the capital, a little bit, but you have high sensitivity, especially because of high infant mortality in the southeastern. This area happens to be, and we'll talk about that, but it happens to be one of the areas that's now affected by the insurrection in Mali, and where there's high levels of mortality related to armed groups and vigilante groups. And then and this is now, it wasn't the case at the time that we did this work. Adaptive capacity, you could see, is more widely, there's sort of moderate levels of adaptive capacity. By the way, this scaling here, and the scaling is important. Now, maps communicate, and you need to choose your scale ultimately. We just took the 0 to 100 and we mapped it directly. But you could equally well do quintiles, and I'll show you a quintile version of this map later. The quintile version basically says, for all the grid cells, we're going to take an equal number in the bottom fifth, the middle, up to the top fifth, and we're going to take the number of grid cells that are in each one. Just to show you that you can also look at these variables in terms of like these maps in terms of the population covered by so the highest risk areas, even though it looks like a large area, is only basically affecting 5% or 6% of the population, whereas medium high is around 30% and it goes down. The most risk is right in these orange areas, both densely settled and also quite, I say risk. See, I just changed it. It's vulnerability. So it's easy to slip up. It's really about vulnerability. So vulnerability is a construct. I already mentioned that it can't be necessarily directly observable. I can't go up to any individual in this room and say you're high or low vulnerability. It can also be considered a pejorative by some communities, so you have to be careful how you use it. People don't want to be necessarily labeled as vulnerable. They might want to be labeled as resilient or, capable. Vulnerable doesn't necessarily have good connotations everywhere. Index construction, I mentioned, there's just a bunch of things that go into index construction that mean you have to pay a lot of attention to details. 15 minutes. And then data available in many developing countries may be out of date, of low spatial resolution, of low validity and reliability. So this was an issue we faced in Mali. We were able to get our hands on some pretty seemingly high quality data, but I looked at some of them and I said, this doesn't pass the sniff test, right? I'm looking at these data, they don't quite jibe with what I might know about Mali. There was a poverty map that seemed to be kind of like showing speckles of high and low poverty next to each other. And things like that, you need to be kind of just use your intuition and maybe a little bit of your knowledge and common sense to sort out. But that results in uncertainty. Data transformations. So that was your question back there. Yeah.
In the development of the index, the variable having very high correlation.
Yeah. Yeah.
So why we should take the variables which are having very high correlation among themselves?
Let me get to that. You're always anticipating. You have great questions. So we'll talk about that in a second. So this is just to say that we had data that were, for instance, from the demographic and health surveys that were point estimates because they take cluster level. They don't want to reveal the populations in each location where they sampled. So they take, let's say, 100 households, and then they don't randomly, but they assign a cluster point, but they may even offset the cluster point a little bit because they don't want to identify the households that are associated. It's very sensitive information. Things like AIDS and things like that were asked about the people who. So basically, some of these were point level data, and so we had to do kriging. Spatial kriging means you basically create a linear interpolation between the space. So many of you are familiar with these concepts. Some of them were already in raster format, but might have needed to be converted to a common raster grid. So what we do is a raster to point first. So you get the centroids of every, I think we did that. And then we took the points and we regridded using a common regrid of 1 kilometer basis. So everything was essentially everything was harmonized according to a common grid. And then they had some things that are polygon data, and then you would just basically do an equal allocation of the value for that polygon. And so that shows some of the uncertainties that come because you may have data at the commune level, but you may have data available at the point level for DHS clusters, and you're interpolating between them. So that's great if you have commune level data, but if like infant mortality, all you have is region level data, which is their kind of equivalent to states. So these are issues that we faced, and I won't say that we could completely overcome them, but it just, you have to be transparent about some of the issues. FuseNet had data from, these are the CHIRTS data, and it was a very high resolution for climate data. But you would have to realize that underlying that is the meteorological station network, which was very sparse. So they're using a combination of met stations and satellite data to come up with these measures. And then I already mentioned the anthropogenic biomes, which are at 1 kilometer. But again, part of the reason I wanted to include anthropogenic biomes is they very clearly delineate these areas of rice growing in the north that have higher potential incomes. Then we also used projections of climate to look at future climate vulnerability. And one of the things we did is in some of the RCP 8.5 scenarios down here, what you see is we actually go up above 100 because we didn't want to use the original scale, but we wanted to show that there's additional vulnerability as a result of the climate exposure. So that tends to be a relatively small part of the country up here, but you get the idea. We were trying to convey that there's actually additional vulnerability. Generally speaking, what you would see is if you compared the original version to the 2050 version, is vulnerability shifts northward. So generally speaking, you see a higher vulnerability in the north. So one of the things I mentioned was about the Met station data. And so we wanted to look at the standard error for temperature and rainfall based on the Met station network that we had available. Lower errors in white, higher errors in darker colors. And what you see is Bamako and some of the cities like Mopti and over here is Kai. They had good Met station measurement, but the rest was just interpolated or using satellite data. So we convey uncertainty in the data here by looking at the Met station. Here we take a look at areas that had higher or lower sampling for the demographic and health surveys. So the white areas, again, have higher resolution data. So what you could say is generally we have much more confidence in Bamako and the areas in the southeast of the country than we do in other parts of the country for these measurements. We also looked at PCA. So this gets to your question. So if you use a PCA approach, principal components analysis, you're taking into account the fact that there's high multicollinearity among some of the variables. And then we simply looked at using newly identified PCA. I'm not sure if I have a slide describing the individual components. I'm not sure I included it. But what you see here is the map of the PCA base and a map using quintiles rather than strictly following the 0 to 20, 20 to 40, 40 to 60 categories. So the quintile map actually does, what we wanted to do is essentially say, if you were to use PCA, would you get dramatically different results? And we found that generally speaking, the results were somewhat comparable, but the additive version has a higher vulnerability in this zone right here than the PCA version. So I do have a map, but I don't have the individual variables that went into each of these principal components. But the maps basically show your climate principal component, your household vulnerability principal component, your child stunting, Africa, the transportation, access to markets, etc. So each of these represents a different component. Because the PCs are uncorrelated, the scores associated with each PC encapsulate a unique aspect of the overall socio-ecological vulnerability represented by the original data set. So those of you who are more familiar with PCA, you understand that process, but we can talk about it more when we construct an index for India. We also did sensitivity analysis. So we looked at what happens if you change the weighting of the variables. So weighting, if we did equal weighting rather than increase the weight of some variables like the demographic and health survey data, which we did increase the weight on, you see that red areas indicate higher vulnerability in the unweighted index. Yellow to blue indicate lower vulnerability in the unweighted index. So when you do the unweighted index, things look a little better over here and a little worse over here. And then we provided documentation. So what does this mean? We show how we transformed each variable, and then for each of the indicators that we use and the variables that went into those indicators, we basically had a full citation of the data set, computational approach to processing it, what were the statistics for the raw data, what were the ways that we transform the data, the spatial resolution of each data set, and then we had a rationale somewhere in here for why we included it up here. And the rationale was supposed to map to vulnerability. So in this one, it's household wealth index. High levels of household wealth are assumed to contribute to greater resilience, while low levels of household wealth are assumed to lead to greater sensitivity to climate shocks, with greater likelihood that households will need to sell assets or migrate during periods of prolonged drought. So that was our rationale for including household. And then we had limitations on each of the data sets as well, what some of the limitations were. We did do, after this, we had worked with colleagues at USAID, and we trained them in the methodology for doing this climate vulnerability mapping. That's why if you see in the readings, there's a step-by-step guide to vulnerability mapping, that was developed in part for our colleague at USAID, and then we refined it with a visiting scholar who came and visited with us, Ibrahim Idris, who is from Djibouti. And anyway, the point is that we did some further analysis. We did some further mapping in West Africa, including in Niger and Burkina Faso. I say we loosely because it was really this guy, Jeremy Chevrier. Jeremy worked with USAID, and he got trained in our methods. And what we wanted to do was see how these maps were actually being used in policy contexts. And we basically used a framework that's widely used now that basically says that the uptake of information and policy processes is determined by three major criteria: credibility, salience, and legitimacy. So credibility meaning, do people believe that your work is actually, strong? Is it good or not? Do they believe in it? Salience means at the time you present the work, is it actually something that policymakers care about? Do they actually care about it, or is it one of those things like under the current Trump administration, vulnerability, schmulnerability, we don't need this anymore, where we don't care about that. And so salience is important for uptake, because if it's not salient, the decision maker won't act on it. And legitimacy, credibility really has to do with your scientific method. Legitimacy is kind of like, oh, Columbia developed this. Oh, Yale developed this. Or, oh, Jamia Millia Islamia University developed it. And they have a good reputation. And so, but they also can be in terms of whether it's viewed as participatory or not. Was there actually an adequate amount of consultation in the process of developing the index or not? We did have some opportunities to interact with people in Mali on and off, and they gave us some feedback early on in some of the things that we were doing with the mapping, so that was it. Embeddedness is the last characteristic, and that means is the mapping actually, or the index, is it actually embedded in a government process? So in some countries, what you'll notice is indices actually become barometers of whether you're doing your job or not, whether the ministry is performing its responsibilities or not. And so if an index is actually formally embedded within a government process, you can bet that the technicians and the civil servants are going to pay attention to that particular index and you're going to want to meet that challenge. Maps are important boundary objects. This is a concept that basically, the way I describe it is, if you're a public health expert, or you're coming from water resources, or you're fisheries, or whatever, you each come at the issue of vulnerability from a very different perspective. And so in the case of Mali, what we found was the maps served in a way that others had documented they served, is that it becomes a conversation point, a starting point for talking about whether you believe or have distrust, maybe even in some of the results that you see in the map. So, but it's a boundary object in the sense that it enhances conversation across different sectoral interests. With power comes responsibility. We learned that from who? It was Spider-Man, right? So with power comes responsibility. And so we need to emphasize and be transparent in the methods that we use and discuss limitations. There are a bunch of questions that we wanted to ask and we hope to get funding to get into further, like what's map literacy like among decision makers? Do they actually, like, my wife can't read a map. You know, it's no shade on her. She has many other strengths. But maps, forget it. Like I tell her in the car, look ahead on the road to see if we can get to a rest stop or go to a gas station. I don't know, where are we going and what are we doing? So that's just like her capability. Like that's not her area of strength. In the same way, we might imagine the decision makers don't necessarily have the ability. They weren't trained necessarily in thinking about spatial data and spatial knowledge. So you can go down this list, but there are a lot of things like, do the results conform with their preconceived notions about the way the world is? And if the maps don't conform, then immediately they'll say, where'd you get that data for such and such? Oh, that came from some international source. We only trust our local hydrology department, you know, that kind of thing. So these are things that we've encountered over the years. All right. All of you should have read, it was in the assigned reading, and maybe, you know, I'm going to run out of time to go through this in very much detail. I just want to be respectful of everyone's time. Oh, I'm down to 29 seconds. Not good. All right. So this was our meta-analysis of vulnerability mapping. I want to skip through the kind of like what the composition of the sample was, because that's interesting, but you can read about that in the journal article. But one thing just to point out, that most of the indices that we looked at for vulnerability mapping, again, this is using, it's like the Mali mapping we did, but we took a sample of like 75 to 80 different cases around the world and looked at the methods that they use. So that's the idea, was we took a large sample. It's 84, sorry. So we had a group of people, so we didn't just do it, I didn't do it on my own, but we did coding, and then we coded according to what we thought was best, and then we compared our coding, and where there are discrepancies, we had got together and we talked through those and came up with a common understanding. So most of the maps use index construction with components. A number of them use index constructions, but without necessarily separating it into separate components. And then components constructed, but no index, so they didn't actually aggregate it up. And then some use things like PCA. And let's just look. These are some of the climate-related indicators that were viewed, mapped. So these are the things that they were worried about vulnerability to: temperature, precipitation, flood, drought, etc. Some of the other indicators they looked at were things like land use, land cover, vegetation, distance. And so a lot of different climate parameters. That's not so important. 50% of studies relied on linear aggregation of the index construction. 62% use weighting of some sort. Again, these are all subjective decisions that come along. There are other approaches like cluster analysis, GIANs. And then at each stage of index construction, it's just important that, you know, this is where the subjective part comes in. Choice of indicators, analysis scale, measurement errors, transformation, normalization, factor retention, weighting. These all influence your results. Uncertainty analysis is important. We found that uncertainty analysis was only conducted by 40% of our studies. 20%, however, it was only textual. So it's basically saying, we know there's uncertainties here. We know that you know, we don't have a perfect grasp of all these things, but that was all they talked about. 18% actually provided quantitative assessment of the uncertainty, and 2% represented maps to support quantification. Anyway, we also talk about mapping and how there's actually best practices in mapping, and some people aren't really aware of that. Obviously, a lot of the journal articles that we looked at, they were written by scientists, mostly for scientists, even though they usually had a sentence at the very end saying, this is vital for policy. But they don't really specify, and they don't really show that they actually made an effort to talk to policymakers. So, but if you're going to start talking to policymakers, start looking at best practices for map construction, because it's really critical. You can at least eliminate some of the lack of geographic literacy or reduce it by starting to look at better approaches to mapping. I'll skip some of this in the bottom. I think validation is a really, so I talked about SSPs yesterday. Only recently have people begun to use SSPs for projecting future socioeconomic scenarios in vulnerability mapping. The big challenge here is that you have multiple scenarios. So you can't map just one outcome like this is the way things are going to look like in the future. We could do that with the Mali mapping because we held all the social vulnerability elements static and just said, if you take today's picture and you overlay on it a future climate, this is what it would look like. But we know that the social systems are evolving too. So you would want to look at future socioeconomic pathways. Validation is important, emergent phenomena that makes it difficult to measure. So, I mentioned already several times that you can't directly measure vulnerability. So what can you do? One is you can look at the outcome measure, like I said, we did in that study of the SOVI and looked at flood and disaster outcomes, flood outcomes. So we looked at floods, and we looked at outcomes in terms of loss and damage, both deaths and damages to housing. And that was a form of external validation. And we found that the SOVI was reasonably predictive, at least in the United States, of damages, or actually of deaths. Damages a little bit less so. Internal validation is when you do things like sensitivity analysis, or you look at alternative ways of constructing your metric, your index, and you say, based on these decisions I made, this gives a certain level of, like we did with the PCA. PCA looked kind of like the original vulnerability map, so we kind of said, you know what, these two are pretty similar, and so therefore there's a certain amount of internal validity or coherence to the approach that we address. And finally, these are just some recommendations for vulnerability mapping. Maybe when we talk about index construction, I'll come back to these for another lecture. So for now, what I'll do is just pass the mic around and we can do a little Q&A. I know you're all hungry too, so... but we started, I think, 5 or 10 minutes late, so maybe we'll just give a few questions.
Thank you, Professor. If I want to study multiple indexes on the same geographical area simultaneously, so what would be the interplay between those indexes, and what should be the better approach? Do we have to overlay all the indexes, or do we have to reassign the weights to develop a new one? Thank you.
So when you're saying multiple indices, do you mean developed by different groups, like maybe comparing for the same state of India, an index developed by one group versus 2 or 3 other groups? I think there could be multiple methods. You could look at RMSE, the root mean square error, is one metric of divergence. You could look at spatially just how they line up against each other with some visual interpretation. I'm sure there's, among our geospatial experts here, there's even more methods that could be used. My guess is that for any given index, it's going to have a different purpose in mind. So depending on the purpose, the results will vary, And remember, back when we were talking about vulnerability metrics, was it yesterday? Day one. Anyway, when we talked about that, we said for any index or any vulnerability measurement or assessment, you're looking at the vulnerability of a group or people or system, or maybe an economic livelihood like fisheries, to a stressor at a particular place and time. And so because of that, you're unlikely to probably find 3 or 4 independent indices that purport to measure exactly the same thing. Does that make sense? Yeah.
Thank you so much for this lecture, sir. So my question revolves around the data credibility these days, which you talked about. So when we are presenting our research, like Indian research abroad in conferences, when we mention the source of the data, there is always some second guesses, because obviously the audience there is not well versed with the situation and circumstances in Indian context. So, and sir, there's a key problem here, that the climate perception amongst the audience, which I worked in my thesis also as a add-on, it is I won't say different, but it is not at par with the reality of the climate changes. For example, if we talk about the rainfall variability or something, so there's a perception amongst people, but when it comes to scientific findings, according to the data, it comes out to be sometimes a very astonishing finding at a very grassroots level. So, sir, when we are presenting the research, people have some doubts about the data credibility, that maybe these results are somewhere probably not well presented or cooked or somewhere like that. So, sir, how do we, counter that, or how do we tackle that kind of a situation? Because the perception of climate change is still in the audience not at par with the reality of presenting it according to a sample size, like a city, Indian city, to a foreign audience. Thank you, sir.
So you're talking about presenting results of Indian research to foreign audiences? Yeah, well, yeah, well, so I think all you can, so, I'm a data person fundamentally. Like, a lot of my work has been around data preservation, data management, data documentation, and that sort of thing. And why I emphasize the need for metadata in the Mali case is ultimately you need to know where the data came from, their provenance, the methods that were used to develop the data. As a scientist, that's your responsibility. Now, how you communicate that to the end user or the audience is basically, you can't just wave your hands and say, these data, you to some degree in a verbal presentation, you can only present so much, but you should have the backup material in your report, and that should be available for anyone who wants to, investigate or dig deeper. And I have had, my fair share of cases where someone basically says that's nonsense. But usually it's even if it's a decision maker, it's someone who has training as an engineer or a scientist. And they basically, they call you to account. So you have to be ready and be prepared for sure. Yeah. Are there any one or two more? Okay.
Sir, actually, I have a little concern about the vulnerability mapping. So, can I go with the Mali mapping of the vulnerability mapping of Mali? Yes, sir. Yes, sir. This would be okay. So, sir, my concern is that if we map the vulnerability mapping, so it shows that normally, if we see that in the places close to the equator or in the northern part, so like it shows that the northern places are a little more vulnerable. But if we look into the population distribution in the northern parts, the concentration of population is like comparatively less. So during the policy making or during the basic perception, so it clears that those areas in the northern part, those areas more vulnerable, but the number of population or the population distribution of those areas are less comparatively. So during the policy making, I think we need to consider that if the southern part, the area is less vulnerable, in the less vulnerable zone, but the number of population affected by the climatic disaster or the climatic vulnerability, the number of people are numerous. So we should we like more to concern about rather the vulnerability zone. So we, I think we also need to consider the population distribution of or the number of population affected by those vulnerabilities.
No, that's perfect, and that actually illustrates. This slide illustrates the point. What happened was actually USAID, funded a follow-on effort in Mali called the Climate adaptations. I don't know. There was some sort of climate adaptation activity in Mali. And they actually did choose this area because it's both the most populated, the orange area I'm referring to. So just around Mopti. And they focused on that area, I think in part because it was a moderate vulnerability. It wasn't at the highest level of vulnerability, meaning that it wasn't in a place where maybe your interventions would not have much impact, but it also was an area that had a relatively robust population that could be helped. We have a hand here. And then, my friend in the back.
Thank you, Alex. Can you go back to that table of indicators in which you have the time frame? Yep. So my question is regarding the temporal range. So it's a good idea to have, I think, long-term ranges for annual rainfall, temperature, and all these data sets. My question is that will it be a good idea if we take similar ranges for all the data sets? And one more thing, in addition to this one, we are talking about the climate change. Will it be a good idea if we take long-term averages post 2000 era? Because pre 2000 era, things have changed drastically in reference to the temperature, precipitation, the patterns have changed over time. And we are considering the long-term average way back from 1950s to 2009. So my query are two queries. One is that will it be a good idea to use the same time frame for all the data sets? And as we are talking about the climate change, so will it be a good idea to take the latest data sets? Because I think it will generate a good output.
So just to recall, this was conducted around 2014, 2013 actually was when the work was done. So the data may appear very old. In many cases, they are old, but they were the best available at the time we did the analysis. You can't really, unfortunately, for most of the social vulnerability variables, we didn't have time series. So it would have been lovely to have time series for a lot of the social indicators, but we didn't have those. We could have, and this is actually a good and valid point, the demographic and health survey has been conducted in multiple waves. So we might have been able to construct some change in certain variables, but that would you need to presuppose that we actually had the same exact measurement. So for household wealth, could we get the same indicators in the earlier waves as we have in the later waves? So you're bringing up some really important points. As far as the time frame, yeah, you could say going back to 1950 for trends may not be that valuable. We were trying to give a sense of like the longer term trajectory. And at that time, if we had started in 2000, we would have had data only up to say, what was the latest date? 2009. So we would have only had 9 years. Yeah, you would hopefully go for data post 2000, maybe. Yes.
Alex, my question is, or inquiry is regarding the indexes which has been developed is mostly classical in nature because weighted and PCA based. Now, in the scenario of machine learning based algorithm come into the picture, where are these indexes is going to look like? How do you see application of machine learning in index development?
That's a great question, and I'm going to leave that to your generation to develop in part because I haven't been using machine learning tremendously, or AI, for instance, is possible. Like GeoAI is now rising in terms of its importance, and people are looking at. I guess what I would say is, as long as it's relatively transparent and not a complete black box, then machine learning it can be a really valuable thing. And there are certainly advances. I'm going to actually take it upon myself to look up to see if there's literature on this kind of index construction using machine learning and see what the literature shows today. Because I have to be honest, I haven't looked at it, looked at that particular question. Thank you. Yes, and one last question, I think we'll break for lunch. Raman's not here to tell us we have to get out of here, motioning us to leave, but I'm going to take it upon myself to.
Thank you, Professor. I just really wanted to know what are the criteria selection for what are the criteria for the selection of indicator for assessment of urban vulnerability, considering that each cities has different meteorological topography and all these different conditions. So considering that, I really wanted how to define these indicator in that terms. Sorry.
Well, that's the beauty of index construction. You get to choose, right? So you have data for your city. You can choose what you think are important variables, and provided you can get data for them, you can actually start measuring things that might not be feasible at. One of the things that I didn't show work we did when we moved from Mali to the regional scale. We did something on the entire coast of West Africa. And that was interesting exercise, but what we couldn't do is get comparable data across all countries. So we were reduced to a reduced set of data because you wanted to have the same metrics apply everywhere. And in the case of a single city, think going down to a local scale, you might be able to get data from your local planning office that we would never dream of at a national or regional scale. Does that make sense? Am I answering your question?
Plain areas, comparing the plain areas and the mountainous areas. In that perspective, what are the selection criteria in that manner?
Okay, I'm going to say the same thing. Essentially, it's vulnerability of what? In this case, is it to heat, or is it to flood, or is it to drought? To what? So it's a vulnerability of what? The city. Sorry, to what? The flood, drought, heat in a particular time or place. And so you will want to choose your indicators based on the risk factors that you think are most important. If it's a floodplain, then it's going to be flooding more likely. It could be also extreme heat. If you're way up in the Himalayas somewhere, it's going to be landslide risk. It's going to be rainfall, flooding, and maybe some other metric that I'm not thinking of, glacial lake outflows. Does that make sense? We can talk more. Anyway, I don't want to keep you from lunch, so let's go ahead and break. Is that right? Are we doing that? Is that what we're doing? Okay.
Right. So I welcome you back to this post-lunch session on the third day of this GIAN program. Yesterday we have a very good tutorial, interactive, a very good participation from your side with foreign expert, and this is another very good session. I hope it will be a good session in the sense that this is not the theory, this is the practical. So in the last 2.5 days, we have learned, we have seen a lot of data on climate change, migration, displacement, and so on. So very interesting data. But this session, I'll be demonstrating you what are data set, from where you can get it, how you can convert it in GIS domain, and then how can you run the model on your own. It is a big exercise, but the data what we have, the spatial data in terms of satellite data and non-spatial data which is available for a very long time, that has made the task better, easy, and that gives a very good result. Earlier, if you have to have a data on climate, on rainfall and all, you have to spend months and months. But now these data is at your hand. You can download in half an hour, depending upon how many sessions you have for how long. So the title what we have is that of exercise 1. Uh, and the title is Climate Change Vulnerability Assessment using Climate Extreme Indices, a fuzzy logic based approach. Fuzzy logic based approach. So if you see this one, from where all data we can get it, uh, when we want to model, uh, climate change, and I said yesterday and today also that when we talk about climate change, two most important drivers of climate change is temperature and precipitation, and everything room around it. With varying temperature, vegetation change. With varying rainfall, vegetation change. Crop change. Everything gets changed. So what we have, from where we need to get the data? The data we get it from India Meteorological Department portal, and portal is already given, imdpune.gov.in. That is headquarters is in Pune. Right. Earlier, when we started research, we have to write a letter. We have sent to speed post, registered post, and then it takes months and months to. You can get the data daily, long-term graded climate data. For this exercise, we have taken the temperature and precipitation, and from temperature we have taken a few indicators, different indices, and for rainfall we have taken different indicators, indices. That can be downloaded. User can download state-wise graded data. You can define your boundary, and based on that boundary, within that boundary, you can download that station-wise and the boundary-wise. Or give lat-long extent you can give. Okay, say for example 77 to 79 longitude, 28 to 29 or 30 latitude. You can make a grid, describe whatever. Or in India, we do not have the state, very state boundary like in US. If you see United States of America, 50 states, they have very straight boundaries. But in India, we have zigzag boundary. Most of the countries have. So you can get the extent, latitude, longitude, and go to the IMD Python library. IMD Python library is this one, IMD library read threshold document dot in dot and then slash latest. Python user can install library using pip install imd lib and fetch data using import imd lib library. And useful, it is very useful. You can retrieve, you can download, extract the very useful information on rainfall and temperature and many more things, right? You can note it down and then make a, maybe you can make a photo, or I will share them, all the presentation PPTs on the drive that has been created for this course. Let me, what happened? Okay. इस पे निकाला मुझे उसको स्लाइड से बढ़ा दो. I'll move it. उसको करके दो मुझे. Then what you have? I put the screenshot. I have made this PPT with the help of my students so that anyone layman can understand how to do it and how to get it. This is website, what I showed you, imdpune.gov.in, and this is the, what you have to do, you have to register like Google, Yahoo account, create an account, and then you go for different data format, radar data, station data, report data, tabular data, and then once you create an account, you can log in and go ahead, right? Then still not working. देखो क्या हुआ, करके दो ना, move करके दो, ऐसे क्यों? Then what you do is, you go to this yearly graded rainfall data. This is 0.5 quarter inch by quarter inch data binary. You have 1 degree also, quarter degree also, right? This is for the rainfall data, and you can go for clickable sample, photon code, and there are different codes here. Nothing to worry about the codes. You can get the codes, and you do not need to understand much of the codes. But you download it and then use that code to run that, right? Then still not working. चला के दिखाओ ना, तुम हमको क्यों पकड़ा दो, कहाँ चल रहा है? कहाँ मूव हो रहा है स्लाइड? स्लाइड्स कहाँ मूव हो रहा है? स्लाइड शुड मूव ना? स्लाइड इज नॉट, उसको निकाला है? यहाँ लगाना है, तुम लोग भी क्या कर, इसका वो लगाया नहीं। अब वो निकाल दिया तो चलेगा फिर? I'm sorry for interruption, right? Then you get this kind of data, graded data, 1 degree graded data, right? So this is use IMD graded data, daily precipitation, maximum minimum temperature. Convert this data into Excel format using Python code, right? And then save this file as a Excel file, .xlx. And then after that, you save that file as a text format so that you can use in RStudio statistical software. So there are 3 issues. One is convert data into Excel format, use a Python code. When you click earlier on our earlier slide I showed you, you'll get the code, and then save that file as XLX as a text file. So this is a graded data. You can see these are the grids. Square shape. There are 3 grids here. There are 3 grids here. You can see maybe somewhere 1 grid, 2 grid. Then this grid data has to be converted into XLS format. What is written? No, .xlx. What is that? The .xlx format. So you see, this is the year 1984, and it's very long row. We use this data from 1984 to 2024, and daily data, daily rainfall data, and this is the month, and this is day 1, 2, 3, 4, 5. This is a screenshot of that. And then what we have, these are the parameters, and this is the date and time. So what we have, how much rainfall has been recorded. Here you see, there is no rain on this day, there is no rain, there is some rain here, there is some rain here, like that. Then what we did, we convert this data to the text format, the last point what we have. 1964, it will get converted to this format, you know. So from graded data to XLS format and then to text format. These are 3 steps. These are 3 steps. Then in RStudio, you go on this Climax website. Website is already given here. Climax project offers a range of climate extreme indices. These indices are annually or monthly statistics for modeling observed climatic data. So what we have? These are the different indices. Somebody was asking yesterday about the indices. Yesterday somebody asked. I said I'll show you tomorrow. So these are the n number of indices what we have. These are the heat and cold indices. What we have? FD, SU. I put here for some FD, that is number of frost days, FD. Number of frost days. This is annual count of days when temperature, daily minimum temperature is less than 0 degrees centigrade. So the second parameter, SU. SU is the summer days. Number of summer days. Annual count of days when temperature maximum maximum temperature is more than 25. Yesterday some participants were talking about, okay, we have a data, yes, is sitting there. Okay, we have a data of more than 25 degrees centigrade, and in India all the year round we have, bearing January, December or November, we have more than 25 days. So data is more general, but it is not so. The expert sitting at the Columbia Climate Institute and many other institutes, they customize, they put it, they make it in a way that it should represent fairly to the different regions, right? So this is another indicator. Then ID, you have IC days, number of IC days, annual count of days when daily maximum temperature was less than 0 degrees. Similarly, you have n number of data, see, more than 20 data, and these are the codes. When you click it, you will get what is this. Then heat and cold waves. These are the different indices. And when you go for precipitation, this is RX 1 day, RX 5 day. So this is RX 1 day, that is maximum monthly maximum 1 day precipitation. 5-day RX, 5-day, that is monthly maximum consecutive 5 days precipitation. R20 mm, that is a annual count of days when precipitation was more than 20 millimeter or more. Right. So we took this data, we took this data, we took this data. You can select the data, and I yesterday told you that you have to select the parameter and the data indicator. You cannot take all because of time, and and there's no point taking all. So you have to read the literature. Okay, which data will be useful for my study area? You take certain parameter, choose certain parameter, run the model, see the result, and always say, yesterday I was saying, do not go for statistics, go to the field, validate. If not, come back and take another parameter and run the model. Right? You need to run the model. You should not be in a hurry. So these are the indices that is available on the website. What I have put it there. Right? If you have any issue, please raise your hand, discuss, because this is not theory class, this is a lab exercise. So you note it down and raise your hand, we can clear immediately on the same, right, on the same point. Now, following are the folders. These are folders for indices. These are the folders for indices. When you go to this, you will get certain indices. You go to this, you will get certain indices, right? And these are the codes. These are the codes. So what we have, see here, these are indices. There are definitions, say 27 core indices. What I showed you, FD, frost days, and similarly these are the little bit explanation what is all about. Not just one line, what is all about. TG, be the daily mean temperature on a day that is in a year. J is a count of number of days between first consecutive occurrence of at least 6 consecutive days, and so on. So very precise, very fine, refined parameter has been made, and accordingly data has been put by the scientists on these portals. No, just wait. Sorry, I pressed this one. It's coming. By mistake, I pressed this one. It's coming. वहाँ पे तो नहीं हिला नहीं यहाँ तो नहीं हिला It's coming, wait. It's coming. Wait. हाँ ठीक है आ रहा है. Right. Then what we do? We took, we took 6 indices. In fact, he has taken 18 indices. Resolve is part of resolve work. We took it to demonstrate you how we can model the climate vulnerability. We took 6 indices to save time for your exercise. Extreme indices, that is there on the top for 20 station. Is a part of Bias River Basin. From that, there are 20 stations. There are 20 watershed, therefore there are 20 stations. So what we have? We join the results of these indices in ArcMag for visualization. From this point of further, the GIS software starts. Till now, what you need to do is go to IMD website, download the gridded data, convert it into XLX, and then convert it to text format. Right? And before that, you need to select the justified, judicious selection of parameters. Once you get it, you have to create a shapefile of a study area with point data where you will going to link it. Because when you say the rainfall, what we used to have earlier, at a large station, there were hardly meteorological station, and even today, there are few meteorology stations, weather stations. It is difficult to install, difficult to monitor it, just difficult to maintain it. In that context, what has been done? The agencies are using satellite data, and that has been converted to grid data, and then you convert it to for each and every location in a pixel format. So in the sense, there was no data, we have quite close to the reality, the data. From where we have got it? Yesterday what I talked about, power of remote sensing satellite data. Right? So this is a dot text file. So what we do is, we input here, We input here this file, and then इसको मैं यहाँ रखता हूँ. Somebody play from there, otherwise इससे हो जाए. एक आदमी वहाँ खड़े जाओ. Right. The text file, go back for one more back. और जाओ, और पीछे जाओ. Yes, this text file, the third output, we already got it. Go further. We upload this file. Here in our Climax Dex software. Then we go for output. We click on the output, load data, and then click. Then we get the output like this. Right. So what we get? This is the basin number 1. It can be name. It could be number. Latitude and longitude in meter. You know, latitude, longitude. Normally we read in degree, minute, and second. But when you go in image processing software, GIS software, we convert it to UTM projection, and then it is in a meter. So what we have? These are the indices. T and M. This is a temperature. This is a maximum temperature. This is rainfall. This is rainfall, and this is CCDs, consecutive dry days. CWD, consecutive wet days. Next, please click karo. So these are the indices. You know what he has taken. Say first indices. Maximum 1 day precipitation. See the third column. Maximum 5 day precipitation. Consecutive dry days. Consecutive wet days. Annual total wet days precipitation. Daily precipitation intensity. That is very important. What we have seen today. You know. This is daily precipitation. Number of heavy rain days. Number of very heavy rainy days. Then in temperature, maximum temperature, TXS, TNX, maximum temperature, minimum, mean temperature, minimum, maximum temperature, minimum, maximum, minimum temperature, and then mean temperature. The number of cool night. This is another very interesting parameter. Number of cool nights, number of hot nights, number of hot days, number of cool days, number of warm nights, number of hot days. Sometimes we experience hot days but cool night. Sometimes we experience hot night but cool days, something like that, because of certain reasons. And these are the units. These are the units, somewhere in millimeter per day, somewhere in degree centigrade, somewhere in a percentage. Next, please. Now, then we go to add extreme climate indices data to station attribute table and visualize in the ArcGIS software. What we do? This is after calculating 9 indices for every station from 1964 to 2023. It is how much? It is 64 years. And to have a better result, we need to have longer period of data. Data is available even beyond say 1964. I think from 1920 or 18, 1901. Imagine. So you can take 1901, but we took it 1964 because after getting freedom and then mostly started some other activities little later. So therefore we can take from 1984 also. Add a station shape file in a GIS software. Join manually, edit attribute table and export to the new file for visual. Next, please. I'll show you now. This is I've already showed you. Next, please. Now we have come to the spatial platform, geospatial platform. What we have? This is a main window of ArcGIS software. We add this is a basin boundary. You need to digitize it. From where you can get it? You can get it from watershed atlas. It's very common. It's very important. Watershed atlas. Therefore, I say GIS and remote thing do not give everything. You need to use. Somebody asked yesterday कि पुरानी चीजें कुछ था कि पुरानी चीजें क्या obsolete हो गई या कैसे होगा. तो then I said कि this topo shade still holds its value. We have the watershed atlas. From the watershed atlas, what is the study area? You reference it and then digitize, and these are the centroid of each watershed boundary. And then वहां से वो तार हिल रहा है, ये दिस वन जो इससे कनेक्ट हो रहा है, दैट इज अ प्रॉब्लम है. उसको बुलाओ, कॉल हिम, कॉल दैट टेक्नीशियन है. अभी हम सॉफ्टवेयर पे आएंगे ना, उससे कैसे करोगे, वी हैव द सॉफ्टवेयर हियर ना. उसको बुलाओ टेक्नीशियन को. व्हाट वी हैव, we link it. I'll show you how to put it step by step. We link it. जो लोग करते हैं जानते हैं, उनके लिए बहुत आसान है. But those who are not doing, for them, once we link it, you'll get the attribute data that is linked in a special domain. Next, please. Then we go and ArcGIS. There is a operating toolbox. That is toolbox. In toolbox, go to spatial analysis, then go to interpolation and do interpolation. There are n number of interpolation techniques. One is very commonly used. One of the best interpolation technique is IDW, inverse weighted distance. There is another technique that is called moving average. There is another called kriging. There is another co-kriging. Many. So I do not want to go into those details. You must be knowing. If not, then you need to see the textbook. Call the technician. That is the only solution. आदिल को बुलाने कोई गया, फोन करो उसको, उसको ऊपर जाओ, go and ask. Okay, then these are different steps. You chose a file, consecutive dry days CDTD, and give the extension TIFF and define the cell size, because each satellite data is own cell size, right? So 30 meter, if you are using Astra data 30 meter, if you are using any other data 60 meter, then you have to have the same cell size of this IMD data. Then go to processing extent and select the basin, and then these are the steps. I'll show you in the software. Next, please. Yes, this is one. Go to the software toolbox. What is written here? Spatial analysis. ये देखिए बहुत डिस्टर्ब कर रहा है. What is the problem? जल्दी देखिए. So what I have written here is spatial analysis arc toolbox. This is the arc toolbox, right? Then from there you go to spatial analysis here, and then from here you click on this cross, go to interpolation, and these are the interpolation techniques. As I told you, IDW, kriging, natural neighbor, spyline, these are the interpolation technique. So this is, ये क्यों चला जा रहा है आदिल? तो आप ठीक से कनेक्ट करिए ना प्लीज. कुछ नीचे लगा दिए, सपोर्ट दे दीजिए. कुछ नीचे उसके कागज लगा दिए, कोई चीज लगाइए. क्या करेंगे? अभी तक तो ठीक था सब, इसका क्यों दिक्कत डिस्टर्ब कर रहा है? Right. So what we have here is these are interpolation technique, and these are the main window for modeling. And once you click on any this cross, you'll find many. Once you click on this say spatial analysis, the major category, you'll find many. In the spatial there, convolution, density, distance, extraction, many. So once you click this one, you'll find many operations. And wherever you get the hammer, That is the last step. You double click and then go for operating. That is operating tool. Right. We'll see in the software. Then after interpolation, you get this kind of map where the consecutive dry days values varies from 0.2 to 0.7. So before that we interpolate. After interpolation we go for fuzzy membership, because when interpolate there will be a wide range of values depending on temperatures in some different unit, precipitation in some different unit, right? As you have seen, something in degree, something in percentage. So you need to convert into a uniform platform. Unless you do not convert into a uniform platform, you cannot draw any meaningful information. For example, if any data of 30 meter, you have data of 5 meter, you have data of 60 meter, and if you overlay, that will give the poor result. So you need to resample at a common scale. So similarly, all these data has to be converted into fuzzy membership. So once we convert these data into fuzzy membership, that values ranges from 0 to 1. So all the layers, you have 6 layers, 18 layers, 20 layers, 100 layers, whatever, that will come on a uniform platform. Then we give the fuzzy membership, we have scaled raster data as input, and then we apply operator. The third line we see gamma operator. In GIS theory you must have studied, or you will see in the textbook, there are different Boolean operators, logical operators, X, or not, right? So in the same way, add, subtract. So in the same way, you apply a gamma operator, and then on the all 6 layer, and then you get the, see here, these are the different output layers, 6 output layer that has been prepared using the meteorological data. These data layers are in TIFF form, right? Tagged information system form, tagged information format. So all these data has to be converted to fuzzy membership. And for that, what you have to do, go to again Arc Toolbox, go for a spatial analysis, and then you go for overlay. In overlay, there is a fuzzy membership. You apply the fuzzy membership, select each layer, and then give the operating overlay method gamma, and then you give the output here. And that will be the final output of that particular one layer. So once you prepare data, it will take hardly a minute to run the model for converting the data layers into a common scalable format. Right? If you have any issue, any doubt, please raise your hand and let me know. Right? Then after that, what we do is, once we apply it, this operator, fuzzy membership, we use all, and then we go for climate vulnerability modeling by using all the 6 layers, and we get the final output map, what I showed yesterday. And this is a vulnerability map where you have the low 0.3 to high 0.7. It varies from 0 to 1, right? And then what we did, we use the census data, population data. The census data, we already know that we have the census data. We go that census data in Excel format. That population data has to be again linked with the point data, centroid data of each basin. If you have 20 basin, 30 basin, or anything statewide, so then you need to do export that map, and then after exporting you need to overlay separately. Use this data from Census of India. We all know this is not new to you. This is population interpolation, population overlaying and making into different classes. Say for example, this is the population data from Census of India 2011. These are the state, this is district, this is sub-districts, population, area and density. You can use population density, you can population total number of population, you can use density, and then you see what is the state of affair in terms of population, in terms of total population or density. Whatever you want to overlay or see the relation. Once we overlay it, the one outpost was separate, my vulnerability map, that is the most important, and then the population map. This is what I study showed you. These big blue dots has a population of 1 lakh or more than 1 lakh. So that shows what is state of affair, how much people are exposed to climate vulnerability issues by using these 6 indices, right? So this is all about Rome. If we talk in terms of presentation, step by step, we have noted it down. I'll supply it to you on the website, this portal, Google Drive, sorry, and then we'll move on the software. And I'll show you step by step. You can see, you can note it down, small point, write a spatial analysis dash something, and then with that note and with this note, we'll move to the departmental lab. Very good, rich lab. इसको ऊपर ले आओ जरा, इसलिए कि फिर yeah, I can sit down. ये इसके साथ लगा रहेगा तो ये डिस्टर्ब करेगा. हाँ. अभी तक तो नहीं हिल रहा था, क्या बात है? अरे तो मुझे तो अब एक बार हो जाएगा, फिर मूव नहीं करना मुझे. Okay. So, friends, this is the हटा दो उसको. This is important, stage, and you need to be careful and watchful, right? Once you have installed software in your laptop or desktop, there is icon here bottom, right? Arc map 10.8. Version does not matter. Even version 8 is fair enough, right? So click on this and then the software will open in a moment. It was open, I close it just to show you. So this is the main window, right? Two windows will open, you close this top window, right? And then I go to this point, this is a symbol here, it says add data plus, right? Or you can go to file and go to add data, and there is another symbol here, plus add data. The shortcut is already placed here, so I go here. There are different options, I'm showing just two options. This one, add data. You need to click on this, where is your data? Browse your data where you have put it, right? I made a folder, and the same folder you'll find in a lab with the same name, so that there will be not any problem. Then there is an option here, look in. Go to a directory, it is on desktop, where I put it. Okay, just wait. मैं यहाँ से ले लेता हूँ. There is another option, there is a plus symbol here. let me do. This is plus symbol. If you go here look in, it will not show all the directory. Go to this point plus, and then you'll find here. These are the directory. See, this PC. On this PC, you can go and CD whatever you have a data. We have a data here in the flash drive. I'll go select here, and then there is a data here. GIAN exercise 1. This is a folder where the same folder GIAN exercise 1 you'll find on the computer lab in department on the desktop. All the system they have put it, data in the morning. You select it, and then you go to this file. This is called, sorry, this one, and then say okay, right? इसमें सारा डेटा नहीं डाला था क्या? एक्सरसाइज V1 ही है तो फोल्डर डेस्कटॉप पे डाल देते ना. Yes, this is folder. We need to add n number of data layer can be added one by one to overlay it, to superimpose it. So I can go say this is a basin polygon. This is outer boundary of the Beas River basin, right? Which is the extent of our area of interest. We add this one, then again go to plus. We add another one, that is station data. We add it. This is point data, right? And then we add it again, the third layer, that is sub-basin data, the spatial data. So you can add one or another n number of layers, right? If it is the same projection and same frame, it has the same projection, it has the same datum, everything has to be same. In a way that चाबी जब ही लगेगी जब उस ताले की चाबी होगी, तो चाहे जितनी चाबी हो लगा दो, अगर थोड़ा सा फर्क होगा तो it will not come. So therefore in GIS the most important aspect is referencing, georeferencing. That we call is referencing any map with respect to surface of the earth by using different information, and the most important is coordinate system, datum, and UTM projection, whatever your projection you want to have depending on different parts of the surface of the earth, and then extent and some other information. So you use georeference. The more precise you reference, the more precise it will land on a particular part of surface of the earth. Otherwise, if you extract certain feature, that may land somewhere else. It has to be very precise. So these are the three layers, right? Then if I go on this data, you see left side, this is a layer, table of content. Sometime it goes away, I cross it, it go away. तो बच्चे कहते हैं आप कहोगे कहाँ गया? Go to window and then say table of content, it will come again, right? Many times it happens. So if I go on this, I need to see what is the attribute attached to it. So there is no attribute attached to it. I have put it all these steps. Attribute means these are the station 19 and 10, 20 basins, and these are the centroids of each basin. When you calculate the centroid, software does it automatically where it has to be placed. Or if you know that particular point, you go and extract that particular point. To extract, we go for digitization. There are three ways of digitizing. One is line feature, point feature, and polygon feature. We all know. And these are the only three features all the phenomena, all the any object have on the surface of the earth, be it a natural or human. If we talk about a river, it is a linear feature. If we talk about human canals, it is a linear feature. If you want to map, it could be linear feature. If you want to see any pole and a chimney, any tower, it has a point feature. Or you take any forest area, you take any agriculture area, or built up area, it will be a polygon feature, right? So once you have referenced that map, and if you draw your cursor on a map, that will give you the area, perimeter, length, or if it is a point, it will give you a coordinate, right? So what we have, these are the only data what we have. These are name, number, and these are the latitude and longitude, right? Then we have a station data from text data we have somewhere else, you know. So we need to add it. We convert it in text later on. So what we have the data in tabular form. That is relational data. That is called, when we talk about data structure, that is a relational data structure. It has one river basin has its relation with several other climatic parameters. So what we do is, let me show you this Excel data separately. These are the data what we have. We have derived from the first part what I showed you. So by using all those data, say from 64 to 24, 60 years and more than 60 year data, daily average, imagine, so 60 days, and then we have converted it and we have got this mean, the one figure. See, this is one figure for this, for particular station. So you get, these are the 6 layers, 1, 2, 3, 4, 5 and 6. So this output we get it here. And then what we need to do is, we need to link it. This point data, see, this is in isolation. This special map point is in isolation. Excel is in isolation. And the most powerful part of GIS is linking spatial and non-spatial data. That cannot be done anywhere. आपको एक मैप दे दें, इसी तरह मैप प्रिंट करके दे दें, और एक्सेल जो सेंसस बुकलेट, मोटी मोटी बुकलेट देता था, कई 100 पेजेस होते थे, आप कुछ कर पाओगे? जिंदगी निकल जाएगी, आप कुछ नहीं कर पाओगे. The most beautiful aspect and powerful component of GIS is linking spatial and non-spatial data. Or not only linking spatial and non-spatial data, it also link different data in a different, which is in different format on a common platform. And that is most beautiful aspect. बहुत पहले एक नेताजी थे, चंद्रबाबू नायडू, अभी चीफ मिनिस्टर हैं, और ये सीताराम येचुरी, ये लोग बहुत इज्जत देते थे, लोग बहुत उनके वैल्यू थी. क्यों? कि कोई भी पार्टी हो, कोई सी आइडियोलॉजी हो, उनको एक प्लेटफॉर्म पे लाते थे. ये बहुत बड़ा वो ना उसका कैरेक्टरिस्टिक्स है, बहुत बड़ी क्वालिटी है कि सबको अलग अलग आइडियोलॉजी के एक साथ लाओ ताकि कुछ काम हो मिलके. अगर अलग अलग करोगे तो नहीं होगा. देन कोalition गवर्नमेंट स्टार्टेड. तो सेम वे वी हैव, तो यू नीड टू लिंक दिस पॉइंट डेटा विद दिस point data with the data what we have created, we have made by using those indices. So it will take hardly a minute. For that what we do is, इसको हम close करते हैं. यहाँ पे देखिए, and to link one very important issue. Just a minute. To link, it has to be unique key. यूनिक की कि जो आपका एक एट्रीब्यूट फाइल ये है एक्सेल फॉर्मेट में, और दूसरा एट्रीब्यूट फाइल ये है ना. ये कौन सी फाइल है? इस मैप का है. और ये क्या है? एक्सेल फाइल है, सेपरेट फाइल है. तो इट हैज टू बी यूनिक की. यूनिक की के लिए सी देखिए, इट हैज टू बी ये A00BE1 कहा गया 17 है ना. आप जाओगे तो इफ यू सी A0BE104, दिस इज हियर, राइट. सो यहाँ पे 20 है, तो 20 वही चीज यहाँ होनी चाहिए. सो सपोज दिस इज 17 हियर एंड 17 हियर, दिस वैल्यू विल गो टू दिस पॉइंट and it has to be unique key. These two, spatial and non-spatial data, can be linked only when you have a unique key. Or you can create a separate column here. You can add a separate column. You can put the name ABCD, or you can write whatever you say, Delhi, Bombay, Calcutta. But it is always good to have a unique key as a number, because typing कभी गलत हो जाएगा तो अटैच नहीं होगा and error आएगा. So these are the two unique keys. Based on these, or you can have a FID. Based on this unique key, what we do is we link it. So let us do it in a minute. इसके लिए हम इसमें जाते हैं, सब बंद कर देते हैं हम. No need to open all these. We go to this file, right? Right click and go to option join and relate. What we do is, ये हमने खोला हुआ है, इसको राइट क्लिक करिए यहाँ पे लाके, join and relate. Go to join, right? Go to join. Join में जाएंगे तो इस saying join attributes from a table. मैप तो ऑलरेडी डिस्प्लेड है, टेबल अलग पड़ा हुआ है कहीं सिस्टम में. We'll keep it here. Choose the field in this layer that the joining will be based on what we are going to. What is the key unique key name? So key name is name. That is based in name. What I showed you, na? And then this is choose the table to join this layer or load the table from. This is already here. Choose the table. We choose the table. We browse from here. यहाँ पे जाएंगे हम. यहाँ से हम browse करते हैं. Browse and go to the table. There is a table here. कौन सा टेबल? इसके नीचे. Indices. This is a Excel table, right? You double click. Sorry. We select this. Indices and add. क्या कह रहा है? Indices नहीं है क्या? Why is this giving the problem? नहीं. उसको पीछे आओ, उसको सेलेक्ट करके ऐड करो. ये क्यों कर रहा है ऐसा? नीचे वाले हो. खुला तो नहीं है? यही तो है ना? खुला तो था. दोबारा सेव करते हैं. Let me save as a separate file. The error in the file, I saved it again. So let me browse the file. इसको कौन सा फोल्डर में डाल दिया इधर? Indices 2 किया ना हमने. यहाँ पर कहाँ indices 2 कहाँ गया सर? क्या कर रहा था? Indices 2 था ना? वो कहाँ गया? यार exercise 1 है. Exercise 1 तो ही है. इसे just bear with me a minute. कहाँ है? नहीं कहाँ where is that? Name? Where is the file? Indices 2. This is indices 2. We add it and then we take the name, right? And say OK. Let us see. Can you see here? It is only 3 column. Now all the data which was there in relation data format, in tabular format, it has joined here. Right? Now, if you click here, take this identifier key and click on this any point, you get the details. See the details. FID is 1, latitude is this, longitude is this, and then these are the values. Can you see? TNM, TXM, this is the value. You click anywhere or you click here, you'll get the value where, what is this point. So this is the linking. That is the most important aspect of here. Linking spatial and non-spatial data. Once you have linked it, after linking what you need to do is, if you close it, it will go away. All exercises will be gone. So you need to save it as a separate file so that it can be permanently saved. So one more step, very simple. What we do is go and select here and say select none. Killer selection. So what I do is, after linking, go to this file again, right? From where we joined, we right click and went to join and relate, right? यहाँ पे क्या हमने दोनों को choose किया? I'll go here down and say data. Go down, right click and data, and there is an option right side, export data. Right? Export data. You click on the export data and then browse to a folder where you want to see as a separate file. The original file will remain as same as such. There will no change there. So you browse from here, and this is my working directory. I go from here. This is exercise 1, GIAN exercise 1, and say OK. Select and say OK. Let me do it again. नहीं तो ब्यास बेसिन दे रहा है ना. नो हाँ तुम लोग बहुत अंदर चलेगा ना. That should not be. कौन था वहाँ तो हम जा ही रहे हैं. हाँ is there research में आ रहा है नहीं आ रहा है. You should have gone so inside. Data इतना अंदर नहीं डालते. हमने बोला था कि बाहर डालो. चलो put it on D, leave it. D में छोड़ो. So you select your this is GIAN exercise 1. Now it comes. So you give a new name, and to make sure, because you have n number of files, and each file has n number of support files. तो बहुत मुश्किल होता है. सॉफ्टवेयर में एक फाइल डिस्प्ले होगा लेकिन उसका सपोर्ट फाइल 4-5 होती है. तो इट इज ऑलवेज गुड टू हैव द सेम नेम. कि इसको क्या करेंगे हम इस पे, आई राइट इट हियर, ज्वाइंट, JOIND, ज्वाइंट, export output, and that will be shape file. I say OK and say OK. It says you want to add it. I say no. I close all and then we'll see. इसको सब हम बंद कर देते हैं. इस पॉइंट को हम हटा देते हैं, राइट. और फिर इसको जब हम ओपन करेंगे तो व्हाट आई सी हियर, हमने कहाँ डाला, ज्वाइंट एक्सपोर्ट, राइट. एंड देन यू चेक इट, ऑल द डेटा इज देयर. आप नीचे इसको ड्रैग करके जाओगे तो सारा डेटा आपको मिल जाएगा. कैन यू सी, राइट. एंड इफ आई ऐड a layer, special layer, what I had before, you will not find the data. Where is the idea? If I go this station data, and if I see this one, it will be only latitude and longitude. So be careful, after joining you have to export map, right? So this is one step. इसके बाद next step, if you have any issue, please let me know. Otherwise, I'm sure that we'll have many issues when you go to the lab, when you start doing yourself. So first is IMD data, grid data we have converted to relational data tablet format में किया. उसको करने के बाद then what we have done, we have gone to the GIS software, we have attached data. The second step. Then the third step is that to interpolate. Because before GIS, we did not know the value. If say this is a rainfall here, 30 millimeter, here say 40 millimeter, what is the rainfall in between? Nobody knows. And there was no data. You know? So what we have, once we are using these 2-point data and we interpolate, then we get the value of any point. When you put your pen anywhere in between इसके चारों तरफ, wherever you put your point, you'll get the rainfall value. So that will be very close to ground reality. So at a time where then there was no data, but you have very close, precise data, much closer to the ground reality. So that is the beauty of interpolation. So how it works is a strong mathematical calculation, triangulation. आपने पढ़ा होगा. Say for example in one line अगर हम एग्जाम्पल दें जो बच्चों हम देते हैं, हम यहाँ खड़े हैं, this is my coordinate है ना, x y and y होगा कुछ, latitude longitude. If I move here, change हो गया, latitude same रहेगा but longitude बदल गया. If I move here, latitude longitude दोनों बदल गया. And my position with your position will also change. आप you are static, but मैं change हुआ तो मेरे respect में आपकी भी लोकेशन बदली. So it triangulates. Trigonometric operation use करके the software developer have done it so that you get the precise values. It's very complex, network data. So जो values ये 20 हमारे हैं, इन सबको लेते हुए कि यहाँ घट रहा है, यहाँ if I go from here, it is increasing or decreasing. If I go up this side, it is increasing or decreasing with respect to this of this value, and based on that, it takes the precise value which gives you the spatial data interpolation. So let us do it. The second step, and for that there is icon here. यहाँ पे देखिए छोटे छोटे tools हैं, and this is most powerful tool. तिजोरी ये है GIS की. Click on this, and these are major, modeling domains. जैसे मैंने कहा यहाँ पे क्लिक करोगे तो बहुत सारे आ गए, फिर इस पे क्लिक करोगे तो बहुत सारे फिर आ गए, फिर इस पे क्लिक करोगे तो बहुत सारे आए, हजारों हजार हैं. We do not know much, we know little. My students know more than me, much more than me. शायद आप में से बहुत सारे लोग जानते होंगे. तो हम लोग उतना जानते एक्सप्लोर करते हैं जो चीज़ें हमें ज़रूरत होती, जो अपने रिसर्च में एप्लीकेशन करते हैं, जो इम्पॉर्टेंट है. We keep on learning, we keep on doing. Now let us go. There is a main tool, that is spatial analysis tool. Click on this, and then we go for interpolation, right? Then there is an option IDW, inverse distance weighted. The value may change. How the value change? If I'm here, you are somewhere here, there's a 0.10, here's 0.20. So if I'm going to, it will increase. And if I go beyond this point, somewhere beyond, suppose there is a polluting unit, chimney, it is emitting, some pollutants. So if you go away from the source, the value will decrease. And if you come close, the value will increase. Very simple. So in what fashion it will increase or decrease? So inversely proportional to distance. Inverse distance, and that too weighted. Unless you do not assign weight. So this all technical issues is nothing to do with you. Just you need to know something, few fundamental issues. बाकी चीजें करके already रखा हुआ है. Nothing to worry about it, right? So I use this IDW. The moment you get the hammer, इस पर double click करो, right? Choose the input feature. Input feature is joint export map. ये हमारा है. I go and select this, right? अब ये डिस्प्ले में है तो वहां दिख रहा है. अगर डिस्प्ले में नहीं होता तो हम ब्राउज करके ले आते हैं जहां भी हमने सेव कर रखा है. वेरी सिंपल. Then z value, which value you want to interpolate. So I do not want to interpolate latitude, longitude. What I want to interpolate? This one indices. Temperature, minimum, mean. Right? Minimum का भी mean है ये. I select this. Right? And then where it will go? Output raster there. You have to be very sure कि where it is going. Otherwise वो default format में चला जाता है, फिर हम ढूंढते रह जाते हैं. कई बार गलती हो जाती है. I click here and then I go to my drive जहाँ हम काम कर रहे हैं. This is GIAN course exercise 1, right? And I give here what is this value? This value is ये है हमारा, क्या लिया था हमने? हैं? TNM. TNM and dot TIFF. TIF. Do not forget to give the extension. So what I've done? I've done nothing. Go to special NS interpolation IDW. Click on that. Give the input feature. Either it is displayed or kept somewhere else in a folder. And then यहाँ पे दिया हुआ है TNM. और यहाँ पे हमने क्या दिया? You select the parameter one by one, all the 6 or 16, 18, whatever. And then you give the output and say save. Right? Then you go and change here this output cell size. As I mentioned there, 30 meter. I put here 30. Right? क्या हुआ? 30. Sorry. 30 meter. Right? And then go to environment. Why environment? Because I want to interpolate the values within this. I do not want anything beyond that. No? So for that we go to environment and go to processing extent. There is a option processing extent. Click on this, right? And then extent, you defined extent. Extent हमारा क्या है? Basin polygon. Yes. Basin polygon. And that has to be displayed. ये folder में अंदर होगा तो नहीं होगा. That has to be careful. Basin कहाँ गया? Last one, okay. Right? And then go down. 2 more issues you need to do. Raster analysis. Because that has to be converted into raster format, raster data. Click on raster analysis and then cell size. Here also you need to define the cell size. What is that cell size? 30 meter. Click here, as specified below. Select as specified below. Okay? And then it is by default 1, put it 30. Okay? Then go down and then mask. Then go to mask. Mask as a basin point. It has to mask. It has to take it from that. Take the basin polygon. यहाँ तक ठीक है. ये 3-4 चीजें यहाँ आपको चेंज करना. नोट कर लीजिए. यही चीज जो नोट कर रहे हैं, the same thing you have to put it in the lab. Then the last step is parallel processing. Go to parallel processing or make this parallel processing as type 0. यहाँ पे कुछ नहीं, 0 कर दिए. Processing become faster, isn't it? And then after doing this, this is the end, and then say OK. Right? Yes. Sorry? 30. 30 is the cell size. 30 meter by 30 meter. 30 is cell size. Then say OK. Right? तो वहां पे जो हमने चेंज किया वहां के लिए वो लिया इनपुट सारा ओके, एंड देन यू हैव टू डू ओके हियर आल्सो. से ओके. इट्स रनिंग द मॉडल हियर. यू सी डाउन IDW. What has happened? Huh? हाँ error आया ना? What is wrong? Just a moment. I'll do it again. Just see. We have taken this, then we have taken TMX, and then we रुको एक मिनट रुको just a minute, let me put it. रिपोजिटरी क्या?
सर हम यहाँ पे अगर करेंगे ना आउटपुट अब आ जाएगा सही।
रुको तीसरी में क्या? वेट
सर ये रिपोजिटरी आइडेंटिफाई नहीं कर रहा है।
रुको एक मिनट। तो इसीलिए मैं कह रहा था ना कि उस मेन फोल्डर में डालना चाहिए था। दैट इज द प्रॉब्लम यू मेड। इसमें नहीं डालना था। वेट TMX ना, TNM यही था ना? नहीं यही है ना फाइल? नहीं वेट, ठीक है ना? ठीक है ना, बोलो ठीक है ना? TNM
सर ये पॉइंट आ रहा है ना, इसका मतलब ये आइडेंटिफाई नहीं कर पा रहा है।
तो नहीं कर पा रहे, इसीलिए मैं कह रहा था बाहर डाल दो।
जी सर डाल दीजिए बाहर।
कहाँ बाहर?
ई ड्राइव में कहीं पे डाल दीजिए।
डी ड्राइव में डाल दो। तो नहीं है ना? They put it on desktop, they put it on pen drive, so that is the problem. And you have made the same problem in the lab. Desktop, never put on desktop. Should not put in this flash drive. It has to be on the main drive. And बाहर बहुत अंदर जाने पे फिर वो issue होते हैं, you know, folder and subfolder. Then we have to define the cell size 30 meter. Rest of the thing will be same. I'll go to environment. We go to processing extent. We go to the polygon basin, right? And then we go to raster analysis. We go for same as slide below, 30 meter, and then mask as a basin. Then we go to parallel processing. We put it 0, say okay, and then okay. It should come. It takes a lot of time because, you know, big data, it has to interpolate, triangulate. I'm sure it should not give any error. Many times you get error when you do any mistake, or there is some system error or the software error or virus. Now let us see. Can you see this one? Earlier we were having the value of only this point. Now we have the value of any place. This has made the categories. You know? This has made the different zone. You can classify these into 3 zone, 5 zone, 7 zone, 9 zone, depending upon the nature of data and how accurate you want. Right? So this is simple interpolation. And after that, this is half done. इसके आगे फिर चलते हैं. And we do this fuzzy membership. First we do interpolation for all the layers, one by one. No? And then we go for fuzzy membership for all the layers. Then we go for running the vulnerability models. Right? So quickly I'll do it. If you want to have this as a separate layer, you can make it layout straight away. You know? Or you want to have in continuation, or it is not like that कि इसमें same value होगी. But the rainfall will be varying. Even temperature must be varying continuously. But this is one step. So let us do it quickly one by one. Shall I do it? And just you see. मैं माइक रख देता हूँ. अब जरूरत नहीं माइक है. The problem which will come, that will come for the folder only. Put it somewhere else. That is a mistake you did. it will be good for you. You will get a repetition also, so that you, sorry, we go to IDW, right? We give the input layer, same. Only thing what you have to choose is the parameter. We go to XM, the second, right? We go here and we give the, I'll put it here. What is that? TXM. TXM dot TIFF, right? Say save. Then cell size 30. Then we go to environment, go to processing extent, basin polygon, na? Same as basin polygon. Then we go to raster analysis, then say same as specified below. There is reflection also. इधर से भी reflection है, इधर से भी आ रहा है. So that is a problem. 30 meter. Oh, parallel processing, put it 0. Huh? Oh, sorry. ये जल्दीबाजी में कई बार हो जाता है. Processing extent same as basin layer. Raster analysis. Specified board 30 meter, fine. This will be fine. Mask, we missed it. Thank you for reminding. Right? Then parallel processing. Is this fine? Let us see what comes. So your system is slow. Has huge data. क्या? Oh, just wait. It will do whatever. इधर इतना टाइम क्यों लग रहा है क्रिएटिंग में? हाँ, but this is good for the linear feature. नहीं होगा, कैंसिल नहीं होगा. कैंसिल नहीं होगा बच्चे. So 30 meter, then mask, right? Then we go for parallel processing, 0. Say okay and okay. It should come now. So it works. I made a small mistake, because of that it was a problem. So what you have, this is uh, temperature minimum and one is maximum. So if you uncheck this one, this is here, and if you click here and you uncheck this one, you'll see the second layer. And the shortcut is another shortcut, good one, is that go to processing, geoprocessing. You do it just for one layer and go to geo. Instead of going that mask and all, somewhere you made a mistake, you miss it. Human error, हम जल्दीबाजी में रहते हैं, जो मैंने किया है गलती से वो गलत हो गया. So it is good. You do it one layer, जो अभी step बताया मैंने, then you go to geoprocessing and then go here, geoprocessing option. Sorry, result. Sorry, कहाँ गया? Results. राइट रिजल्ट में जाइए एंड दिस इज ITW, ये हमारा ठीक है ना, आइदर दिस और उसके नीचे वाला, दिस इज फाइल ना हमारा, नहीं ऊपर वाला, दिस वन ना, यू क्लिक ऑन दिस एंड देन यू डू नॉट नीड टू डू ऑल, यहाँ पे ऑलरेडी बाय डिफॉल्ट आ जाएगा. ओनली थिंग व्हाट यू हैव टू चेंज इज हियर द थर्ड लेयर, दिस वन, द रेनफॉल एंड सेल साइज. यहाँ कुछ नहीं करना है आपको, everything will be there, and then output only you need to change. I was going on that. You change the output. What is this layer? TN90P. TN90P, right? Oh sorry, कोई बात नहीं, यहाँ कर देते हैं, एक ही बात है, डॉट टिफ. वी कैन डू इट हियर, ठीक है ना, ठीक है. यही मैं कह रहा हूँ, शैतान कहता है जल्दी करो, गलत करो. Rest you do not do, you don't have to do anything, say okay. So इसमें बहुत टाइम बचेगा. So if you do say 20 layer 30 layer, तो उसमें अच्छा खासा टाइम you can save, but first time you have to do it that way, right? I hope it should work. Results, right? And then go to this layer and only you change the two things. One is input and output. So input is R20 rainfall and then give the output. यहाँ पे आप R20 कर दो, R20 and by dot tif भी है, right? Nothing else. Am I right? Say okay. Right? It works. Then go to geoprocessing, results, double click on this and then you take the input, the second last one, CDDD, and change here. CDD, right? Consecutive dry days, nothing else. Say okay. I think it will take say 10-15 minutes more. The last layer is left. Okay, it also works well. Then the last one, results. Double click on this and give the input, consecutive wet days, and then See, file CWD, right? Okay. So we have all the 6 layer interpolated. 1, 2, 3, 4, 5 and 6. Right? इसका नाम गलत आ गया IDW, but this is not IDW. Right? I made a mistake in typing. Now what you need to go, and that is the beauty of GIS in a sense that if I give you all the 6 layers separately in the print form or digital form, and if I ask you a location, okay, where this condition meets, the XYZ condition, you cannot tell. So the moment you overlay, so manually if you overlay, then even then you cannot get anything. So when we do a special overlay analysis in GIS software, that will give you which one is having this particular characteristics, which say this parameter this much, this parameter this much, something like that. So for that, what we do is last option, second last option, in fact, we go to overlay, right? And we go fuzzy membership, because we want to convert these values. See, the values what you see on the left side. Here you see my cursor, 10 point something something, this is 30 something something, this is 23 something. So we go and we create fuzzy membership so that it can be on a uniform scale from 0 to 1. Right? The same issue, I'll go input raster layer, CWD, and I change the folder here. And it is always good, I advise that you see what is the parameter CWD and then FM, fuzzy member, so that you remember. Otherwise आप भूलते रहोगे, हमें भी नहीं मिलता था, बड़ा मुश्किल होता था फिर, FM and dot TIFF, right? Dot TIFF and say save, right? And then this is a very important issue. There are different option: large, near, small, large and linear. So you need to select one out of these two. How? Logically. Suppose this is, what is that? This is consecutive wet days. So you need to understand logically that wet days plays a positive role or negative role. If it plays a negative role, so what I need to give? Which one I need to select? So wet days is a vulnerability. That means if you have a more rainfall, it is a basin, it is a hilly area, what will happen? Vulnerability will be more. Right? So what I need to choose is large. Isn't it? Huh? So I choose a large. Right? यहाँ पे हम जाएंगे, I choose the membership type large. Right? And I say okay. Right? The same way we need to see कि किसको हमें large देना है, किसको medium देना है, किसको small देना है. And that varies depending upon the indices that you have selected. आ गया नहीं? It comes. आया नहीं है? अब आ गया. See this one. See the beauty of GIS. आप देख रहे हैं? Right? अभी था, that was in bracketed. Okay, this to this much, this to this much. Now, if I put my cursor यहाँ पे, तो एक value दिखाएगा. Pixel value 0.33. If I click here, it will give the pixel value. Otherwise, when I go and see this one, इस पे हम जाएंगे, तो यहाँ पे जब जाएंगे तो ये range दिखा रहा है. So when you go for the range, that is not very close to reality, but it is quite close. So same way, what I need to do is, I need to go for all the layers. We need to convert this IDW inverted map into fuzzy membership. So हम shortcut जाएं. Result जो मैंने पहले किया था क्यों? Then what I do is कहाँ गया? अच्छा नीचे खींच के हमने ले आया. Right, this one. डबल क्लिक किया. हम यहाँ पे लेंगे सेकेंड वन CDD एंड देन इनपुट हो गया एंड देन यहाँ पे हम चेंज करेंगे CDD. राइट, डॉट टिफ है ऑलरेडी. डॉट के पास है और सॉरी FM. हाँ नाम यस FM. वेरी ट्रू. ठीक है ना. अब ये कंसेक्यूटिव ड्राई डेज ये भी अवेलेबिलिटी है. द हॉट डेज so it will be also large. Large is already here. I apply it. Let us see. Yes, it comes. Right? अब इन दोनों को देखो, आप इसको चेक करो तो नीचे कुछ और है. देख रहे हैं ना. These are two different layers. Now quickly I do it to save time. Double click. I select the third one, rainfall, R20, R20 FM, right? Fuzzy membership. अब ये है हमारा रेनफॉल. ये क्या था? रेनफॉल मोर देन 20 mm. Rainfall more than 20 mm. The more the rainfall, more will be the vulnerable, right? So I again take the large and say okay. ये बैटरी इज ड्रेनिंग आउट. पुट इट. अभी बंद हो जाएगा. अडॉप्टर लगाओ. 3 is done. Then the fourth one. I chose TN90, TN90, right? FM. और ये क्या है हमारा? टेम्परेचर, number of hot days. More the hot days, more will be the vulnerability. So it will again a large. What happened? Yes. 4 layers, good. It also works. The last two, I chose the second last one. ये क्या था? IDW. इसका नाम गलत हो गया. TXM, right? I'm sorry. नहीं, I made a mistake. I go here. Input. TXM, huh? TXM. Mean maximum. TXM. Temperature maximum mean, right? Now, maximum temperature again is a plays an important role, major role. So it will again large and say okay. Right? 5 layers we have made it. Good. The last one. TNM. Temperature mean maximum. TNM. right? TNM, and then minimum. This is minimum. So this will not play major role. So it will play minor role. So it will be small, right? ठीक है भाई? I say okay. Okay, we have done all 5 layers. We have made, and you see here, for all the layers, you will have a value ranging from 0 to 1. Not below 0, not more than 1. Now see here, the value what we have 0.7 is showing the lighter. The value 0.9, highest value shows a lighter. So you can invert it. You can change it. Or you can leave it as it is. It's up to you to read. Let me do one for just for one. Let me do it for this one. I go here, go to properties, but no, the top one is displayed. I'll go for the top one. High is lighter. Right click on this layer, go to properties just to display. Value will not change, nothing will change. I go and say invert. Check this one, invert. So lighter is high here. If I convert in check invert and apply, okay. So what you see here? Our system is very slow, but this is i7. Imagine i7 की ये हाल है, because he has big data. बहुत data इनके पास. छोड़ दें क्या इसको? Normally what you have to do is say this one. अब देखो high पे dark हो गया. So that gives a better impression to me. कि if we have a darker, तो वो एक थोड़ा डरावना पिक्चर दिखाता है. लाइटर को कम वैल्यू रखो, इट्स बेटर. कैटेगोरिकली आल्सो फील दैट, तो ये लाइटर. नाउ एंड द लास्ट ऑप्शन, लास्ट स्टेप, कि बाय यूजिंग ऑल दीस 6 लेयर यू हैव टू अगेन मॉडल इट कि which area will be more vulnerable, and for that you have to do one step only. Again here, go to overlay, where spatial analysis, I'll go and show it again. यहाँ पे हम जाते हैं, दोबारा दिखा देते हैं आपको. This is the main toolbox. Go to spatial analysis and then go to overlay. Click on spatial analysis, click on overlay, and then you go fuzzy overlay. The title what I showed you, the fuzzy analytical hierarchical process, fuzzy overlay. Click on this, right? यहाँ पे आप input raster layer. Now my input raster layer will be fuzzy membership layer, not the first one. So I select this one. आगे आए नीचे, just click, it will come down. Second one, this is the third one, and this is the fourth one, this is the sixth one, this is नहीं हो गया सब. नहीं, कौन सा बचा? CWD बचा. It's all well. कौन सा गलत हो गया? हैं? It's fine. It's fine. And then you give the output. अभी कुछ दिखता है चश्मे से? एज हो गई बट अभी भी किसी के पास. Therefore I am saying कि आप आगे आ जाओ. And then this will be the output final layer. Last I say vulnerability. Cli underscore underscore bias, right? Dot dot tif, right? Say save. And the most important, you need to apply gamma overlay type, you know, and then gamma operation point, it is by default. It will go and say okay. Okay. Hope it should work. कोई error ना दे. Yeah, we got it. अब शक्ल जो सुबह दिखाए थे उसे बदला हुआ है, मैं वही शक्ल कर दूंगा. लेट अस सी. इसको हम अनचेक करते हैं. अनचेक से भी नहीं होता आनंदिता. It's always I advise to remove the layer which you do not want. Remove it, otherwise it takes time. So let us remove it. We have done all. इसको हम सब हटा देते हैं. I do not need any layer further. Just give me a minute. I hope you must not be tired. Climate vulnerability. I go to right click, properties, and then go to symbology. यहाँ पे आपके पास n number of जो भी आपको पसंद है कलर, you know, अपने कपड़े का कलर चॉइस करते हैं ना, सूट का कपड़े का जो भी पसंद है वो चूज कर लीजिए. I choose red and green. So where is red and green? This one. और ऊपर हाँ, this one. This one, right. रेड किस साइड है आपका? हाई में. लेट अस से अप्लाई, राइट. जो हमने दिखाया था, बल्कि ग्रीन है. हमने सुबह जो किया था दैट वाज समथिंग डिफरेंट. वो था, क्या था? रेड एंड नहीं, ब्लू नहीं था. दिस वन, दिस वन, यस. रिवर्ट, inverted. Yes. This is 90% done. अभी 10% बचा है पॉपुलेशन ओवरले, है ना? तो if you can bear me with say 5 minutes more, will it be fine? फिर हम चलेंगे डिपार्टमेंट, पहले चाय पिएंगे, फिर उसके बाद कुछ करेंगे, राइट? तो 5 मिनट में बस लेट मी शो यू. जो करते हैं बच्चे उनको तो पता होगा, बट मेनी ऑफ यू मस्ट नॉट बी नोइंग. सो लेट मी. हाँ है, नहीं वहीं चलेंगे ना. क्यों, वो क्या पहुंच गया वहाँ? बोलो वहाँ पहुंचे, हम वहीं पहुंचे. बोलो 5 मिनट पहुंच जाए, हम बस यहाँ से चल पड़ेंगे 5 मिनट में, राइट? सो what we have now, there is another layer we have created for this course, and that is the basin, polygon, sub basin bias, right? This is sub basin. इसको हम चेक कलर हटा देते हैं. I make it hollow so you can see कि कौन सा बेसिन में क्या पोजीशन है, राइट? सो व्हाट आई डू इज, इफ आई गो इन सब डिस्ट्रिक्ट एंड सी द एट्रीब्यूट, यहाँ पे हमारे पास पॉपुलेशन डेटा है. वेयर द पॉपुलेशन डेटा, सो दिस हैज टू बी ओवरलेड सो दैट वी कैन सी कि व्हाट इज स्टेट ऑफ अफेयर, व्हाट आई शोड यू. बिकॉज हमें सिर्फ वल्नरेबिलिटी नहीं देखना है, कितने लोग इम्पैक्ट हो रहे हैं, और अकॉर्डिंगली गवर्नमेंट हैज टू वन हैज टू प्रोड्यूस मेक द पॉलिसी डॉक्यूमेंट कि कैसे उन लोगों को बचाया जाए, कैसे ठीक किया जाए. सो व्हाट वी नीड टू डू इज, इसके ऊपर हम क्या करते हैं, एक लाइन का ऑपरेशन है. वी गो टू दिस वन, जो हमारा जो बेसिन बाउंड्री है, इस बेसिन का हमारे पास दिस वो है सब बेसिन का वाटरशेड का, इसका हमारा डेटा है, कहाँ से, सम एजेंसीज जो पॉपुलेशन डेटा, सेंसस डेटा जो हमने दिखाया था आपको. व्हाट वी डू इज, इस पे हम जाएंगे एंड देन गो टू प्रॉपर्टीज, राइट. एंड प्रॉपर्टीज में जाके वी गो टू सिम्बोलॉजी. देयर इज ऑप्शन हियर सिम्बोलॉजी, नोट इट डाउन, सिम्बोलॉजी. सिम्बोलॉजी में गए एंड quantities, right, and then go to proportional symbol, right, and value field, say population, right, and population में जाने के बाद then यहाँ पे क्लिक करिए and then give the size. थोड़ा हम साइज बड़ा कर देते हैं, right, 10 point कर देते हैं. I put a color, different color, let's say blue color, right, ठीक है, and say okay. इसका बेसिन का कहाँ गया बेसिन का, अच्छा यहाँ, वेट, डबल क्लिक एंड आई मेड अ मिस्टेक, आई हैव टू पुट इट यहाँ पे बैकग्राउंड, आई नीड टू पुट इट हेलो. दिस इज वन आई शोड यू, राइट. अब यहाँ पे हम टोटल पॉपुलेशन को दिखा रहे हैं, यहाँ पे हम पॉपुलेशन डेंसिटी को दिखा सकते हैं, कोई भी चीज दिखा, बिल्टअप को, एनीथिंग, नो. सिमिलरली यू कैन ओवरले अदर डेटा, अदर फीचर which you want to relate with the climate change vulnerability. कितना पॉपुलेशन डिस्प्लेस हो रहा है, कितने पॉपुलेशन इम्पैक्ट कर रहे हैं, कितने कैटल पॉपुलेशन, मैनी मोर थिंग, राइट. आई होप यू कुड हैव लर्न समथिंग. सेम थिंग यू हैव टू डू इट. We'll not let you go before you do yourself, right. So we'll go to department and tomorrow we have a 2 session by Alex here, and then after lunch we'll go straight to the department and we can sit 2 hours, 3 hours as per your wishes. If you can finish in 1 hour, you're free, but you have to do it. Lab is open till 6:30, 7, 8:30, 9:30, doesn't matter. That is in our control. So I hope you should have learned something and you will be able to do it on your own. If you note it down, the steps. Yes, any problem and issue, please let me know. Yes, बताइए. आप इसमें बोलिए, हम भी नहीं सुन रहे. Speak in the mic. Now is, come on. Huh? We do it now. See, it's 4:15. We'll take 5 minutes to reach. Department is very close by, and then we have a tea, 10-15 minutes, and we'll sit and have. I hope you are not tired. Okay, then thank you so much. So this is not the closing of the day. This is the closing of this session demonstration, and then we'll do the lab. In the lab, it will be again recorded. No? Okay, thank you.